At its inception, Fred Hoyle's theory aspired to become the cornerstone of cosmology. Indeed, it was difficult to refute. Most scientists abandoned it only after the discovery of cosmic background radiation in 1965, a prediction of the Big Bang theory which subsequently became the standard model of cosmology. Another favorite topic of Hoyle, the scientific heretic, was the origins of life on Earth, a profoundly vexing question in science. If we exist in an eternal universe, life, along with space and time, might be an inherent property of the cosmos. In the 1970s, with advancements in space exploration, the hypothesis of panspermia transfer of life between celestial bodies regained interest. Hoyle and his student Chandra Wickramasinghe, born in 1939, published numerous papers advocating this unconventional view. The universe is teeming with life. These works brought Hoyle, as Cerdan notes in his essay The Worlds of Fred Hoyle, scandalous fame. The idea of panspermia was rejected by astrophysicists and biologists alike, but found traction among theologians. Undeterred, Hoyle and Wickramasinghe persisted in their work. They proposed that myriad spores and bacteria traverse the cosmos. Some are hidden within cometary nuclei, evolutionary arcs, others are lodged in meteorite crevices, while still more drift unprotected across the cosmic ocean, shielded only by dust. These spores survive their journey, and upon reaching a hospitable environment, they proliferate rapidly, transforming barren landscapes into flourishing ecosystems. Thus began the story of life on Earth. Hoyle and Wickramasinghe substantiated their hypothesis with spectral analysis of cosmic dust, whose infrared spectra closely resemble those of organic matter, particularly desiccated bacteria. Observing radiation from distant galaxies, Wickramasinghe concluded that microbial spores could even traverse galaxies. According to his calculations, the Milky Way alone hosts 10 tons of microbial spores, an astronomical armada, dispersing life across planets and stars, releasing biological payloads onto any solid surface encountered. Encased in protective capsules, these primitive organisms, unlike humanity, the so-called crown of creation, could endure interstellar journeys lasting millions of years. Hoyle also speculated that pathogenic microbes and viruses, such as those causing plague, Hawaii V, and mad cow disease, might originate from space. He argued that the cosmos harbors all the essentials for life, seamlessly blending science with conjecture. His ideas, while intriguing, often eluded empirical validation, leaving them in the realm of belief or speculative fiction. Hoyle, who also wrote science fiction, vividly portrayed these concepts in his novel, The Black Cloud. In it, an ordinary gas dust cloud becomes a colossal sentient entity capable of reasoning and communicating via directed radio signals. Perhaps, he mused, intelligent extraterrestrial beings already surround us, disguised as lifeless components of the universe. With his extraordinary creativity, Hoyle ventured where others hesitated. Could some of his seemingly mythical insights be tomorrow's scientific breakthroughs? The myth of extraterrestrials. Extraterrestrials have long inhabited the imaginations of poets, philosophers, and writers, appearing as saviors, threats, divine messengers, or destructive forces. Humanity's collective mind has explored every conceivable scenario of a great encounter with alien intelligences as rational brethren, or our cosmic adversaries competing for a place under the stars. Immanuel Kant, the great philosopher who marveled at the starry heavens above and the moral law within, believed that neighboring planets in the solar system were inhabited by intelligent beings whose wisdom increased with their distance from the Sunday. By contrast, Nobel laureate Jacques Monod viewed humanity as the sole intelligent species, an accidental product of an indifferent universe. Astronomers too are divided. Some assert that the cosmos abounds with life, while others impose stringent conditions on its emergence, painting Earth as an oasis in a barren desert. The debate over extraterrestrial life is so contentious, the scientific arguments so contradictory, that one often feels trapped at the crossroads of irreconcilable opinions. Lacking firm evidence, these discussions verge on futility. Since the dawn of the space age, despite deploying probes and telescopes, we have found no extraterrestrial organisms, artifacts, or traces of extinct life. What we have gained is a roadmap for the Futura strategy for exploring the cosmos over decades or even centuries. The first frontier is our solar system, where the search is confined to microscopic life. Mars, as well as the moons of Jupiter and Saturn, remain prime candidates for harboring microorganisms, either in the present or the distant past. The second frontier extends to exoplanets. Once a sensational discovery in the constellation Pegasus, exoplanets have since numbered in the thousands. It's no longer surprising to hear about yet another planet discovered by astronomers that is similar in size to Earth. Within the next few decades, a new generation of telescopes will allow us to routinely perform spectral analyses of exoplanet atmospheres located within a radius of a few dozen light-years from Earth. By knowing the composition of these atmospheres, we can judge whether such planets might be habitable. But the much-desired breakthrough may only come with the third strike. It is like the third call in a theater, after which, as scientists dream, the cosmic curtain will rise, revealing the main actor on the universal stage, extraterrestrial intelligence, announcing its presence. Like Immanuel Kant and countless other great and less renowned minds before and after him, we dream of finding not merely lower biological life on other planets or super-Earths, but something greater, intelligent life or older brothers in reason. These beings we hope might guide us toward the pinnacles of civilization. But are our dreams in vain? Are we truly not alone in the universe? Extreme opinions on the matter are well known. Yet is there a reasonable way to assess the likelihood of advanced civilizations in the Milky Way and beyond? Let us delve into some recent calculations by scientists. American astronomers Peter Baruzzi and Molly Peebles have shown that most planets formed a long time ago. 80% of Earth-like planets and 50% of gas giants are at least 4.6 billion years old, meaning they predate our solar system. In our galaxy alone, there may be up to 1 billion Earth-like planets and as many as 10 billion gas giants. Based on this, Baruzzi and Peebles hypothesized the existence of many thousands of civilizations across the Milky Way. Adam Frank from the University of Rochester and Woodruff Sullivan from the University of Washington in Seattle estimated the number of stars in the observable universe to be nearly 1,023. Considering that the Sunday has about a dozen planets orbiting it, the probability of us being alone in the universe is approximately 1 in Ling. This figure does not directly answer whether we are alone, but its sheer improbability hints at a negative answer. Stepping beyond our galaxy, even staunch skeptics might concede the presence of extraterrestrial civilizations elsewhere. Several years ago, American scientists, astronomer Michael Hart and physicist Frank Tipler proposed that our civilization might be the only one in the Milky Way. However, even they acknowledged that among the vast multitude of other galaxies, there must be at least one inhabited planet, potentially home to its own advanced civilization. Yet the distances separating these cosmic islands are so immense that all extraterrestrial civilizations may forever remain isolated from one another. Can we, however, detect real evidence of extraterrestrial life today? With the advent of radio technology, scientists began to ponder whether intelligent life beyond Earth might reveal itself through radio signals. In 1960, American astronomer Frank Drake used a 26-meter radio telescope at the National Radio Astronomy Observatory to monitor signals from two stars Tau Ceti and Epsilon Eridani. Since then, telescopes have repeatedly scanned various sections of the sky, attempting to intercept signals from alien civilizations. All efforts so far have been in vain. This does not mean such signals do not or cannot exist. It simply suggests the challenge is far greater than we imagine. We do not know where to expect the signals to come from. The universe is vast, and the spectrum of frequencies to monitor is equally enormous. Moreover, the cosmos is full of natural radio sources that can confuse scientists. Finally, we cannot even be sure we are looking for the right thing. Do extraterrestrials use radio waves for communication, or have they developed entirely different technologies? Nonetheless, we are entering a new phase of the search. In 2015, the Breakthrough Listen initiative, funded by Russian billionaire Yuri Milner, began. By 2025, its participants aim to study the vicinity of 1 million stars, including several thousand located near the Sunday. Scientists are looking for any traces of artificial processes, evidence of technological activity by the inhabitants of distant star systems. 2 of the world's largest telescopes are at the disposal of astronomers: the Robert C. Byrd Greenbank Telescope in the Northern Hemisphere, with a parabolic mirror over 100 meters in diameter, and the Parkes Radio Telescope in southeastern Australia, with a diameter of 64 meters. Have extraterrestrials ever visited the solar system? This is how the Fermi Paradox was first articulated. Calculations showed that if an extraterrestrial civilization reached the level at which constructing spacecraft became possible, it would not go unnoticed not only by us, but by everyone. If such a civilization emerged, it would need just a few million years to traverse and explore our entire galaxy, visiting every conceivable location. Fermi addressed this issue, much to the delight of pessimists and skeptics. Since no traces of extraterrestrial life have been found so far, it means there simply isn't any. Otherwise, the galaxy would have long been colonized, and our solar system would have been turned over to cosmic colonists, likely reduced to a raw materials appendage of a great civilization. In the late 1980s, British astrophysicist Martin Fogg suggested that our galaxy might have been fully explored and settled by aliens even before the solar system formed. According to his idea, if even one civilization capable of interstellar travel had emerged, it would initiate a systematic colonization of space. Following this logic, all planetary systems in the galaxy could already be central hubs for alien activity. The planetary systems near our solar system might have been inhabited by extraterrestrials for a long time. Even our cosmic home would likely have attracted their attention during Earth's early history. Alien astronauts might have visited, observed specific planets, especially those in the terrestrial group, and perhaps even left monitoring devices to track local fauna, including humans. Do they know about us? But where are they? Where are they all? It's enough to echo Fermi's question, where are they? And where are the traces of millions of people who lived on Earth in ancient times: the Trojans, the Hittites, the Olmecs, the Phoenicians, the Neanderthals, and the Cro-Magnons? Are they buried in the Earth? The idea of searching for alien artifacts left on Earth in ancient times is not new. Erich von Däniken and, more significantly, his followers discredited it long ago with their extravagant discoveries. However, in the spring of 2017, this once dismissed and mocked idea resurfaced in scientific circles. Astrophysicist Jason Wright from Pennsylvania State University published an article on a popular scientific website exploring this controversial notion. So, what if a highly developed civilization existed in the solar system in the distant past? Or perhaps emissaries of distant civilizations visited here? Is it possible to find traces of their existence after hundreds of millions of years? If so, where should we look? Where might extraterrestrial artifacts be buried? In Stanley Kubrick's film 2001, A Space Odyssey, a mythologically documentary-style narrative, as the director described it, humanity's distant ancestors discover a mysterious monolith, a faceted obelisk made of black stone. Millions of years later, astronauts find a similar monolith on the Moon. Of course, for this fantasy alone, suddenly seeming to gain some grounding, one could face harsh criticism. Therefore, it's essential to note that Wright does not claim that a vanished civilization ever existed in our solar system. He merely asks questions: where in the solar system is the likelihood highest to find traces of a lost civilization, and where is it unlikely? Wright's idea may seem unscientific, yet we have no evidence disproving the possibility that aliens visited our planet in the distant past, nor any evidence confirming it. This concept can be dismissed as pure fantasy, but it cannot be definitively proven wrong. If we mentally leave Earth and imagine ourselves on other planets, with a trained perspective of the space age, we can identify several celestial bodies where aliens might once have settled. So where should we look? On Venus, which in the distant past had conditions similar to Earth. However, between 500 and 800 million years ago, Venus underwent massive volcanic eruptions, with powerful lava flows erasing all traces of life. Mars presents a far more intriguing possibility. The surface of the red planet is not fractured into dozens of lithospheric plates heading for recycling. If alien settlements were once built there, they might now lie buried under thick layers of dust, but they wouldn't vanish. Instead, the ruins would be well preserved. Of course, our artificial probes have visited Mars several times, yet nothing has changed. None of our fantastical visions have been confirmed. Perhaps this is because we've been searching for signs of modern, contemporary life on Mars. Specialized equipment capable of detecting deeply buried artifacts in the Martian soil has not been used. The traces of alien space expeditions could be searched even on the neighboring moon, and even more so at the gates of the solar system, on the asteroids that make up the Kuiper Belt. According to Wright, there are many interesting and fascinating species on Earth. Perhaps on these small planets, ancient mines and quarries left by non-human beings will someday be discovered. Or perhaps asteroids were used as cosmic beacons, signal signs of danger, reminding passing starships that turning here toward the Sunday was risky. Thus, it is possible that billions of years ago, on some planets of the solar system, and perhaps even on Earth, extraterrestrials visited, obsessed with the same curiosity that drives our researchers who, like an unknown instinct, are compelled to conquer the moon, colonize Mars, settle on multiple planets at once. In other words, to soar above Earth. That same unknown instinct probably drives a concern in an insect's pupa before it turns into a butterfly. It is possible that in the vastness of the solar system, there were not only individual robotic bases of extraterrestrials, but also a whole network of their settlements on different planets and moons, which was later abandoned or perished. Evaluating our activity in conquering the surrounding cosmic space, we cannot ignore the fact that any other civilization, born hundreds of millions or billions of years ago within the solar system's boundaries, or having penetrated it, would behave in the same way. However, over this time, both worlds have been transformed by new civilizations they created. Their appearance, for example Earth's, has changed so much that the presence of extraterrestrials here in the distant past can only be suspected from the strange ratio of some isotopes. So perhaps amazing discoveries are waiting for cosmic archaeologists on the Moon, Mars, asteroids, or the moons of giant planets. Planet Vulcan. In the 19th century, astronomers discovered that the true orbit of Mercury deviates from the ideal ellipse it should follow according to Kepler's law. After completing an orbit, Mercury does not return to its starting point. In other words, its perihelion, the closest point to the Sunday in its orbit, shifts slightly with each revolution. What could explain this? On the 2nd of January, 1860, Urbain Le Verrier, one of the first scientists to propose a compelling hypothesis during a lecture in Paris, suggested that either a planet smaller than Mercury existed between the Sunday and Mercury, or there was another asteroid belt like the one separating Jupiter's and Mars's orbits. Due to its proximity to the Sunday, these celestial bodies are invisible to observation. They could only be seen during a solar eclipse or when passing across the Sunday's disk. A few months before his lecture, Le Verrier received a letter from amateur astronomer Edmond Lescarbot. He reported that on the 26th of March, 1859, he had discovered a round black spot crossing the Sunday's disk, appearing like a planet. Lescarbot observed this spot for 75 minutes, and during that time it traversed almost a quarter of the solar disk. As a result, when he saw this spot, it appeared to cover nearly a quarter of the solar disk. The correspondent also indicated the inclination of the orbit of the supposed planet. Using this information, Leverrier calculated the period of revolution of this planet as 19 days and 7 hours and its distance from the Sunday. It turned out to be 7 times closer to the Sunday than Earth. Its diameter and mass were much smaller than those of Mercury. Such a planet was too small to account for the discrepancies in Mercury's motion. Could it have been the largest object in a cluster of asteroids that likely surrounds the Sunday? Leverrier became quite fascinated with this mysterious planet, naming it Vulcan. Another correspondent of Leverrier, Professor Rudolf Olf from Zurich, also observed strange spots on the Sunday. Calculations showed that if these were planets, they would be moving in 2 distinct orbits. One had a revolution period of 2 hours, while the second had periods of 26 days and 38 days. The problem is that objects inside Mercury's orbit are very hard to observe because this part of the sky is brightly illuminated by sunlight. Observations in this region can damage telescope optics and are dangerous for astronomers' eyesight. Additionally, due to glare from the bright light, researchers might accidentally see small spots near the sun objects that could be outside of the Sunday zone. But of course, they would not be there. For more than half a century, astronomers tried to detect the hypothetical planet Vulcan. In 1860, a solar eclipse occurred in Spain. It was an event when the Sunday's disk would dim, and the planet or planets near it would emerge from behind the blinding glow. Leverrier called on all French astronomers, as well as several foreign colleagues, to observe the planet Vulcan. However, it could not be found. But this was not a complete failure, nor the collapse of a dream. Leverrier, until the end of his life, was convinced that the volcano planet existed, and shortly before the death of the famous French scientist, new evidence of this was revealed. On the 4th of April, 1875, German astronomer Weber noticed a round spot on the Sunday. Calculations showed that the planet, whose orbit had been previously calculated by Leverrier, and a planet with an orbital period of 38 days, which was allegedly discovered by Rudolf Wolf, should have passed through the Sunday's disk the day before. Did they all coincide to form the volcano planet? And was the one-day difference just a calculation error? Meanwhile, on the 29th of July, 1878, another solar eclipse occurred. Professor of astronomy at the University of Michigan, James Watson, immediately noticed 2 glowing spots. Apparently, 2 small planets located between Mercury and the Sunday. Another American astronomer, Lewis Swift, one of the co-discoverers of the Swift-Tuttle comet, who returned to us in 1992, saw only one star, the volcano planet, but it was located away from the objects discovered by Watson. Should it be said that this time, the location of all 3 planets did not match Leverrier's indications? There was no volcano, but suddenly a quartet of planets appeared. Solar eclipses continued, but the volcano planets stubbornly eluded observation. After many years of unsuccessful searches, most astronomers began to doubt that the ghost planet existed. When Einstein published his general theory of relativity in 1916, it became clear that the peculiarities of Mercury's motion could be perfectly explained using this theory, instead of cluttering the vicinity of the Sunday with planets. According to it, the Sunday bends space and distorts the orbits of planets. If Mercury's motion is described in Euclidean space using Newtonian mechanics, it seems to move too quickly. However, if one turns to Einstein's theory and Euclidean geometry, the anomalies disappear. The difference in calculations is exactly the 43 arcseconds that once prompted Leverrier to invent the volcano planet. Now, it had to be dismissed as unnecessary. In May 1929, wishing to provide definitive information and find out what was happening, German astronomer Erwin Freundlich arrived on Sumatra to observe the total solar eclipse. Later, he carefully examined all the photographic plates, revealing many stars shining on the black sky at daytime, but there was no volcano planet there. The last surge of interest in this planet occurred almost half a century ago in 1970, when several astronomers reported having seen unknown objects close to the Sunday during a total solar eclipse. For example, American astronomer Henry Curtin was sure that he had proven the existence of the volcano planet. According to his calculations, it orbits the Sunday in 11 days, located 0.096 astronomical units away. It is very small, its diameter ranging from 300 to 800 kilometers. But the discovery was not confirmed this time either. For many decades, astronomers have repeatedly observed this planet. What did they really see? The same Lescabo was unlikely to be fantasizing when reporting his discovery. He presented it quite reliably, and such an authoritative astronomer as Livier believed him. Perhaps, say modern astronomers, but like many modern researchers, Lescabo accidentally spotted an asteroid passing close to Earth. Today, similar asteroids are discovered almost every year, but they were unknown at that time. Seeing this mysterious object against the Sunday, Lescabo assumed it was a planet, even closer to the Sunday than Mercury. It is possible that other researchers also saw an asteroid passing across the Sunday's disk, although no such cases have been recorded to date. Experienced astronomers like Swift and Watson, obsessed with finding the volcano planet, might have mistakenly taken stars appearing in the sky during a solar eclipse for it. In Watson's case, this is proven. He classified the stars Theta and Zeta from the constellation Cancer as planets. Curtin likely mistook a comet near the Sunday for the volcano planet. Later, astronomers repeatedly observed comets approaching the Sunday. Finally, some errors could have been caused by optical defects. For this reason, some amateur astronomers might have mistaken a speck for an unknown planet. Popular lore has long associated the planet Mars with the god of war. Its red face appeared blood-stained. At the end of the 19th century, the bloody Mars suddenly became the planet of life. In 1877, Italian astronomer Giovanni Schiaparelli, known for his extraordinary sharp vision, noticed strange thin lines on Mars. He called them canali, which in Italian means channels. They connected dark spots, Martian spots, and they were mostly wet. In 1936, he highlighted polar caps among them. Schiaparelli believed that the channels were depressions of natural origin, possibly giant riverbeds that connected various bodies of water. Soon, speculations arose that these channels were artificial structures dug by the inhabitants of the planet, the Martians. The channels began in the polar regions. Evidently, during the hot summer months, when the ice melted, it flowed through the channels into the southern arid regions, irrigating fields cultivated by hard-working Martians. The only puzzling thing was this. If people could spot the channels, then their width must have been several hundred kilometers. Otherwise, they wouldn't have been noticed. Who, then, could have dug such wide channels? The answer to this question was suggested by the American Percival Lowell, who founded an observatory in Arizona in 1894, specifically for observing the Martian channels. According to him, around the channels stretched floodplains covered with dense vegetation. These regions sharply contrasted with the neighboring barren areas. Lowell built the observatory to observe our fellow beings, the Martians, who were allegedly altering the nature of Mars according to their will. Over time, he compiled an extensive map of the Martian channels, estimating their number to be around 700. On the map, they formed a geometrically precise network. Unlike Earth's rivers, which wind like snakes, they were drawn as if on a ruler. It was now hard to deny that these channels had been constructed by intelligent beings. By the turn of the 19th and 20th centuries, few, except for the astronomers, and not even all of them, doubted that Mars was inhabited. The human civilization of Mars had likely surpassed us in many ways and achieved great perfection, wrote the French astronomer Camille Flammarion. Martians had built cities and mastered various arts. Belief in Martians was as fervent as belief in UFOs today. They were the subject of articles in popular newspapers and magazines. Their lives became themes for books by famous writers and a popular plot in mass literature. In 1898, Herbert Wells wrote The War of the Worlds, chronicling the battles with Martian invaders. Similarly, with Bolshevik enthusiasm, the heroes of Alexei Tolstoy's novel Aelita journeyed to Mars in 1922 to 1923. Later, in 1950, came Ray Bradbury's The Martian Chronicles, and in 1955, Isaac Asimov's The Martian Way. We owe the canonical image of an alien to Martian fantasies as well, the small green being with antennae on its head, which appeared in a 1913 comic dedicated to, of course, the adventures of a Martian. Most often, science fiction writers were quick to convince their readers that Mars was inhabited by treacherous, evil beings whose only goal was to invade the meek, trusting Earthlings and seize their homes. A mass panic still lingers in memory, though it's viewed as a curiosity, which gripped thousands of Americans in 1938. It all started with an ordinary radio broadcast. Suddenly, the announcer reported that a giant cylindrical object had just crashed in New Jersey. The next news was even more alarming. From the wreckage of the cylinder emerged a huge creature, wriggling with many tentacles. More creatures followed, and they began attacking people. Panic swept through the population. The terrified public mistook the brilliant hoax for a real broadcast about a Martian colonial army's invasion of Earth. These invincible enemies, as tall as skyscrapers, mercilessly fired, cutting down hapless Americans like grass. People fled from their radios in fear and, jumping into their cars, sped away in all directions. Some even tried to kill themselves to avoid the arrival of the invaders. American director Orson Welles, the creator of the controversial production, did not anticipate such a response, not a triumph, but a psychosis. It's astonishing that this enthusiasm and fear were, for the most part, sparked by nothing more than an optical illusion. In this film, we will see how in the old world, great men like many others were unable to act as they wished. The human brain tends to replace a series of dots or dashes with solid lines. Nowadays, people are sometimes ready to interpret any atmospheric phenomenon as a UFO. In the early 20th century, any dots, spots, or lines noticed on Mars inadvertently formed into a network of channels. Throughout history, proponents of the most bizarre hypotheses have been willing to substitute facts with their beliefs and fanatic devotion to them. So, reality disproves the theory. What if the cause of this is not related to the economy itself? Since the mid-1870s, Jevons, who had been interested in meteorology since his youth, noticed a factor like weather. With remarkable persistence, he tried to understand what could link the capricious, unpredictable weather and the theoretically stable economy. Suddenly, it occurred to him that, just like in economics, there are fluctuations in meteorology. These can be compared to fluctuations in the economic cycle. However, to explain how a crisis occurs and how the heavenly machinery disrupts the well-established mechanisms of earthly life, economist Jevons had to abandon economics and become a storyteller. He cautiously and skillfully wove a chain of imaginary events that would logically lead to rising prices and stock market panic. Here is one path, opening in the labyrinth of events. But can it be considered the only correct, inevitable one? On the Sunday, spots regularly appear. The Sunday darkens, shines weaker. The weather worsens. There is no good harvest. Grain prices rise, and the stock market looks to the future with gloom and anxiety. People's businesses become increasingly miserable. Both economic crises and solar activity are recurring events. One follows the other. After the dimming of the Sunday, the economy darkens, and a crisis follows. It seems all logical, but is it really inevitable? Jevons turns to historical facts, and here he faces a blow. In 1740, England, judging by solar activity before that, should have experienced a severe crisis. However, this did not happen. Why? Perhaps because the center of world trade at that time was not England, but the Netherlands. Jevons even sent a letter to his economist friend Vissering, asking for help in archival research to establish whether there was a crisis at that time. The response was disheartening. "I found no traces of it. Maybe some crisis did occur, but it was completely forgotten." However, the failure did not prompt Jevons to abandon his initial hypothesis. In any economic crisis, solar activity is to blame. It creates a chain of events that culminates in a stock market crash. In this case, if the scheme is considered inherently correct, the error lies in choosing the wrong indicator of the crisis. Indeed, every time a crisis begins with some event that sets the gloomy tone and forewarns of hard times, it is always some special event. One time, a crisis began when numbers grew quickly, which could not survive. Another time, insurance companies began multiplying. A third time, all the newspapers suddenly began writing about the coming crisis, and it came. Finally, Jevons made his choice grain prices. When they rise quickly, prepare for the worst. At the same time, Jevons chose grain prices in the country where demand for it is especially high in India. There, even a small price increase is very sensitive for the population. Furthermore, India, being a backward country living off agriculture, always suffers from bad weather. Also, a crisis in India, a British colony, inevitably affects the entire European economy. For Jevons himself, his hypothesis was important because the main cause of economic crisis, the sunspots, regularly reminded him of its presence. The spots would grow, and it was time to prepare for the worst. Here, the inexorability of a fundamental physical law could be felt. Knowing the cause, sunspots in such quantities, it seemed that one could confidently predict the consequences. The crisis would begin at a certain time. Contemporaries considered Jevons' theory to be a professor's whim. Today, economists take it more seriously. For example, the American economic historian Philip Mirowski believes that when developing the theory of sunspots, Jevons could not have carried any results. Jevons was perhaps trying for the last time to save the neoclassical market model. It seemed perfect, and any crisis in it could be explained by the random influence of external factors. Jevons' mistake was in trying to explain the very existence of economic cycles with one single cause, and that cause was exogenous, meaning outside the economic sphere. Jevons himself noted Arnold Toynbee in his book Researchers, stating later that periodic economic downturns are, by their nature, psychological, dependent on changes in spirit, optimism, agitation, disappointment, and panic. Nevertheless, it cannot be denied that in part, Jevons was right. We all live under the power of the dominating celestial body. We are sometimes wildly energized when the echoes of distant storms reach us, and at other times we seem to fall into hibernation, tossing off our slippers and pants. As soon as the sun's energy, which fuels humanity, quiets down, and whose energy is often lacking for decisive actions. Not only humans, but all living things on our planet, and even the planet itself, react turbulently to processes occurring on the sun. Apparently, in an era of maximum solar activity, the number of factors that lead to the outbreak and escalation of epidemics increases, wrote Russian scientist Chizevsky. The statistical data collected by him continues to find new confirmations. Before him, many, like Jevons, studied the connection between earthly processes and solar conditions. But only Chizevsky presented heliobiology as an independent field of knowledge. He brilliantly proved that fluctuations in solar activity influence the behavior of the masses, thus affecting the distribution of events over time depending on these influences. And this is not only about using this data, but also about applying it in life. In the fall of 1869, an American named Cyrus Tidd, 1839 to 1908, was conducting alchemical research, He was well known and experienced. He tried to turn lead into gold, but by accident, he received a powerful electric shock that knocked him to the ground. That was when enlightenment struck. While he lay unconscious, an extraordinary vision of the world appeared to him, contradicting what generations of astrologers and astronomers had claimed. The Earth indeed had the shape of a sphere, but it was a hollow sphere. People did not live on its outer surface, but inside the Earth. This was crucial. And inside the sphere, it was filled with the sky and celestial bodies. Why had no scientists from Galileo to Herschel noticed this? Because they all started from a false premise that light travels in a straight line. If this is not the case and light rays bend, then to the observer, the cosmos that opened to him seems infinite. The vision revealed to the semi-dead Tid shattered this illusion. The rest was for him to imagine. The thickness of the Earth's crust beneath our feet, Tid now proclaimed, was only 100 miles. That is, 160 kilometers. The diameter of the sphere in which we are enclosed, like a chick in an egg, reaches only 8,000 miles, 12,875 kilometers. Inside the Earth's sphere, there were 3 additional transparent spherical shells. The atmosphere layer immediately adjacent to the Earth's inner surface, followed by a hydrogen shell, and finally, in the center, a boron shell. But how then to explain the mystery of the Sunday? After all, it brightly shone in the sky, disturbing the harmony of the spheres. In his book Cellular Cosmogony, or The Earth as a Hollow Sphere, published in 1898, Cyrus Tid wrote that the Sunday is an invisible electromagnetic source of energy, located, like many others, at the center of the hollow sphere and rotating around its axis. The visible Sunday is merely a reflection, just like the moon. The Sunday is located just a few thousand kilometers from the concave surface of the Earth. Its size is modest. As for the planets and stars decorating the sky, they do not exist. They are merely numerous reflections of the Sunday's light. The Sunday itself is two-faced, but not only. The Sunday has a light and dark side, and as it completes a full rotation around its axis within 24 hours, it faces us alternately with its light and dark sides. Day and night alternate accordingly. Similarly, Tid explained the change of seasons, shocking astronomers. Physicists were outraged upon learning that only light rays moving directly toward the center of the hollow world travel in a straight line. All other rays move along arcs of circles. The closer light rays pass to the center of the hollow world, the slower they propagate. In its central part, any movement slows down. Thus, the speed of light is not constant. However, for an observer inside the system, this is imperceptible. As for gravity, it is generated by the Sunday. These are special rays emitted by the Sunday, apart from light rays. They then reflect off the metallic layers within the Earth. As in the geocentric system, Earth occupies a special position in this system of the world. Only in Ptolemy's doctrine and medieval cosmological systems, Earth held the central place in the universe. While for Cyrus Tid, the spherical Earth forms the boundary of the visible world we see. However, a question arises. What lies on the other, outer side of the Earth? Could it be that Earth continues infinitely? But here, Tid, the long-suffering, finally awoke. Now he had only one goal in life, to share the revelation he had received the apocalypse of Cyrus. In one night, he transformed from a doctor into the founder of a new faith, a modern prophet. He took a new name, specifically the ancient Hebrew version of his name. He founded a new society, the Corinthian Union. In 1870, the first meeting of the followers of this new doctrine took place in New York. He then went to Chicago and San Francisco. Although there was no large influx of people, his sermons and lectures still gathered enthusiasts who, like him, rejected modern scientific views, as they made Earth appear like a speck of sand lost in the vast cosmos. This encounter prompted him to take further actions. During one of his missionary trips to Chicago, he met the inventor, publisher, and geodesist Ulysses Grant Morrow, 1864 to 1950. They took a liking to each other from the first conversation. Professor Morono now explains why he carried that title during the Parisian Union, deciding as a true scientist to conduct an outstanding scientific experiment and definitively prove Cyrus Tidd's correctness. Morrow designed a giant-sized ruler with which it was possible to mechanically set the horizon at any point on Earth. This device, literally a straightener, was needed by Morrow to measure the curvature of the Earth's surface. This value, he believed, would precisely indicate whether we live on the surface of a convex sphere open to the endless sky or are trapped inside a hollow sphere doomed to gaze into the closed void above us, colored by illusory reflections of a single light. The straightener consisted of 4 segments, each 3.64 meters long. At both ends, perpendicular crossbars were attached, allowing the segments to be joined together. The position of any segment could be adjusted with precision down to a millimeter. The total length of the entire structure, attached to 2 stands, was 14.56 meters. Holes were dug to set up the stands. The rear part of the structure was dismantled, the stands were removed and placed in a new location. The professor only had to reconfigure the assembled device. By May 1897, the structure had been relocated to a new site. At that point, it had covered a distance of 3.08 kilometers and reached the sea. And what did the experimenters achieve with these measurements? The doctrine of eternal ice. On a summer morning in 1925, all known German and Austrian scientists received letters with identical content. A storm of indignation swept through laboratories and libraries. The text was an ultimatum. The time had come to choose whether to stand with us or against us. While Hitler was clearing the politics, he could not be blamed for not being able to be blamed. Hans Herbig is sweeping away false sciences. The doctrine of eternal ice will become the symbol of the renewal of the German people. Know this, join us, or it will be too late. The person who dared to threaten scientists was named just that, Hans Herbig, or in another transcription, Herbig. That year he turned 65. His long gray beard made him look like an enraged prophet. He had every reason to fall into noise and fury. He took it upon himself to preach a truth that people rejected, for it completely contradicted all the basic principles of astronomy and mathematics. Herbig, like a madman, decided to discard the 1,000-year history of science and start everything from a clean slate on which only his name would be written. Objective science is a harmful invention, a totem of decadence. Like Hitler, he believed that the most urgent task was to know who longs to know. Only a prophet like him could engage in science, for the power of his enlightenment elevated him to the highest level of consciousness. Meanwhile, by science, he did not mean what everyone was accustomed to understand by it. Revelations of science were bestowed only to him, he knew no doubt. Any slight objection drove him into a frenzy. "You trust mathematical equations, not me," he thundered. "How much time do you need to finally understand that mathematics is a contemptible lie?" What truth was revealed to him? What is the doctrine of eternal ice? Austrian engineer Hans Herbig, 1860 to 1931, announced his doctrine on the eve of the Great War in 1913. It was bright and insane, like the speech of a madman. According to this teaching, millions of years ago, a giant star resided in the constellation of Cygnus, its mass millions of times greater than the Sunday's mass. One day, a massive planet, composed of water ice with a metallic core, collided with it. Upon impact, the planet's icy surface was covered with a thick slag crust, so it did not melt immediately and remained inside the star for a long time. Eventually, all the water ice evaporated. Inside the star, a huge amount of water vapor accumulated, and it exploded like an overheated steam boiler. The fragments of the star scattered across the universe. The lightest elements were thrown the furthest, forming the shining Milky Way. From the remaining parts of frozen water vapor, the solar system and the ice Milky Way formed, now located 3 times further from the Sunday than Neptune. The entire solar system is filled with countless ice particles and hydrogen clouds, which Herbig called the ether. They hinder the movement of planets, gradually slowing them down. Over time, small planets moved so slowly that they finally collided with larger ones and became their moons. Eventually, all of them would crash onto the surfaces of these planets. In turn, the planets will eventually move closer to the Sunday and evaporate. There are few of them left now. There were over 30 initially. The ring around Saturn is the remnant of intra-Uranus. The outer planets, Mars, Jupiter, Saturn, Uranus, and Neptune, are pure water spheres covered by a thick layer of ice. The inner planets, or helioids, Venus and Mercury, consist mainly of metals. A thin ice crust covers them. This thin ice forms when interplanetary ice blocks, created during the original explosion, fall onto the Sunday. Their fall causes spots on the Sunday while the water vapor evaporates and, after flying off into space, freezes. On Earth, we observe this thin ice in the form of cirrus clouds. Earth occupies a median position in the solar system. It is not covered by a thin ice crust like Venus, nor by kilometer-thick ice layers like the Moon or Mars. The Moon was once a planet, and now is moving towards Earth, and will inevitably break under the weight of its own mass. Its fragments will fall onto Earth, destroying everything in their path. There have already been several such catastrophes in our planet's history. The last time, when the icy fragments of the 6th moon, which crashed into Earth, melted, the biblical flood began. About 12,000 years ago, when Earth captured the current moon, a flood also occurred, and Atlantis perished. Memories of these global catastrophes were preserved in German myths, which tell, among other things, about the twilight of the gods, as well as in the revelations of John the Apostle, Apocalypse. By Herbig's own admission, one day, when he looked at the moon through a telescope for several hours, a revelation came to him. In an instant, he understood that the moon's shine was caused by the fact that it was completely covered in ice. He expected this discovery to bring him immortal fame. A few nights later, he was shown a second revelation. In his sleep, he saw the universe. He saw a silver pendulum that swung uncontrollably, growing larger, and then suddenly broke apart. At that moment, he understood that Newton was wrong, and the gravitational force of the Sunday no longer acted at a distance 3 times greater than the distance from the Sunday to Neptune. Based on these revelations, he created the doctrine of eternal ice. All the universe is an arena of constant struggle between fire and ice, between Neptunism and Plutonism. The solar system was born as a result of a cosmic collision between the fiery mother of the Sunday and the icy giant. In 1913, Herbig published his revelations. It was a hefty, almost 800-page, hard-to-read tome titled Glacial Cosmology, which he had worked on since 1894. From the very beginning of his life, he was in Kiev. When he was in Kiev, he believed that his teachings were infallible, declaring, like Otrozov, "Only that which agrees with me is true, and that which does not agree is false." However, his tome was initially barely noticed by anyone. But after the war, hysteria surrounding Herbig reached its peak. The Society of Eternal Ice and the Herbig Institute in Vienna were founded. The followers of the new doctrine demanded the cancellation of routine astronomy lessons, chanting, "We want Herbig." Fans even emerged among intellectuals. For example, this catastrophic doctrine fascinated the poet Gottfried Benn. Scientists collectively rejected his revelations, but the worse for them, for he was the only German genius. What do these professors say? Can we see in photographs that the Milky Way consists of billions of stars? All these photos are fabricated by reactionary astronomers. His worldview contradicts any calculations made by the celestial hysterics. In this mechanics, these calculations only lead one astray from the true path. To one of his opponents, he bluntly said, "Either you will learn to believe me, or you will become my personal enemy. Herbig did not live to see the Third Reich. However, his teachings inspired the Nazis, who called him the Copernicus of the 20th century. His followers included Hitler, Himmler, and other criminal leaders of the country. The Annenherbe Copernicus Society, established in 1933 to study everything related to the spirit of the Nordic race and integrated into the SS in 1937, did not overlook this doctrine. After all, a war was approaching between the solar Third Reich and the Ice Kingdom. The collapse of the Reich was also the collapse of the eternal ice doctrine. After 1945, it caught the attention of others. In 1935, Copernicus was found guilty of the murder of the solar Third Reich. This was unknown, but reason exists, and the meaning was not in it. For many centuries, people were convinced that the planets were created by God. Only in the 18th century did the first scientific theories appear, explaining the distant past of the solar system. The modern theory of its origin is based on the hypothesis of the 18th century philosopher Immanuel Kant, 1724 to 1804, who was the first to suggest that an extensive nebula of gas and dust once rotated in the place of the solar system. Over time, it condensed and split into a central mass of the Sunday and the surrounding rings from which the planets formed. However, Kant's main astronomical work, The Universal Natural History and Theory of the Heavens of 1755, in which this idea was expressed, did not attract any interest from the scientists of his time. It was only nearly 100 years later that the French astronomer François Arago rediscovered Kant's hypothesis. Several decades later, the French mathematician and astronomer Pierre-Simon Laplace, 1749 to 1827, independently suggested that an extensive nebula of gas and dust had once rotated in the place of the solar system. In 1796, in the last of the 5 volumes of his exposition of the system of the world, which gathered all known astronomical data of the time, he suggested that the solar system originated from a hot gaseous nebula surrounding the Sunday. Today, this theory is known as the Kant-Laplace theory. In the 19th century, it was the widely accepted cosmogonic theory. However, in the second half of the century, British physicist James Maxwell, 1831 to 1879, revealed its flaws. According to his calculations, differential rotation should have prevented the condensation of matter on the periphery of the future solar system. Moreover, it was impossible to explain why 98% of the angular momentum of the solar system is accounted for by planets moving in their orbits, even though their total mass is 750 times less than the Sunday's mass. In the end, British physicist and astronomer James Hopwood Jeans, 1877 to 1946, attempting to explain why the Sunday's angular momentum is so negligibly small, proposed his own hypothesis for the origin of the solar system, which enjoyed popularity among astronomers for 2 decades. Returning to the Sunday in 1916, his hypothesis proved catastrophic. The war played out in the heavens. Another star, like an airplane with bombs heading toward a doomed city, was approaching the Sunday, the lone, calm star. Or more precisely, in the starry sky, the Sunday and the star were inexorably moving closer to each other, just as 2 airplanes would approach each other in a clear starless sky, heading for a collision. But the collision never happened. The powerful tidal forces which arose during the accidental approach of the 2 stars prevented the collision, but at what cost? A vast amount of matter was torn from both stars. When this turbulent matter settled over time, and the foreign star, the disturber of the celestial world, disappeared into the distance, planets formed from this material, now surrounding the Sunday. However, a detailed analysis of Jeans's hypothesis showed its inadequacy, and it was rejected. In modern cosmogony, catastrophic hypotheses are not considered. By the 1940s, astronomers had returned to the Kant-Laplace theory, slightly modifying it. The initial mass of the protoplanets was refined, and the deficit of angular momentum was explained by the action of magnetic forces. Today, this is the generally accepted theory for the origin of the solar system. It can also be added that according to current understanding, the gas-dust nebula that gave rise to our and many other planetary systems was mostly composed of hydrogen and helium, which formed during the Big Bang. Less than 1% was made up of impurities in the form of particles containing heavier elements and compounds, such as water, ammonia, carbon monoxide, and carbon dioxide. Some parts of this nebula compressed and condensed. This could have been caused by explosions of supernovae in close proximity to it. The shock waves generated by these explosions penetrated the nebula, causing clumps to form. These became the embryos of what is believed to be several hundred, possibly even thousands of stars, a star cluster that, after hundreds of millions of years, eventually broke up into many single and binary stars. One of these stars was the Sunday, surrounded by its gas dust cloud. Millions of years passed before planets appeared near the Sunday. The protoplanetary disk from which they formed stretched over billions of kilometers. Its mass could range from 1 to 10% of the mass of the star. According to astronomers' estimates, the formation of the solar system was completed around 4.568 billion years ago, with a margin of error of 2 million years. This conclusion was reached by studying meteorites of a certain type whose composition closely matches that of the protoplanetary disk. According to estimates by astronomers, the formation of the solar system was completed about 4.568 billion years ago, with a margin of error of 2 million years. Scientists reached this conclusion by studying meteorites of a specific type, whose composition is similar to that of the protoplanetary disk. The distance of the planets from the Sunday played a decisive role in the planet formation process. Near the Sunday, refractory substances in compounds primarily condensed, while the solar wind carried volatile substances to the periphery of the solar system where gas giants began to form. The remaining material that was not captured by the planets formed small celestial bodies, comets, and asteroids, which have changed little since the formation of the solar system. Therefore, studying them can help clarify many still unclear aspects of this theory. The search for Trans-Pluto and the abundance of the Kuiper belt. In 1846, the planet Neptune was discovered at the tip of the pen. It was located on the other side of Uranus's orbit. Its visible trajectory slightly deviated from the calculated one. These deviations could only be caused by the gravitational pull of Planet X, as it was called by one of its enthusiastic searchers, the American astronomer Percival Lowell, 1855 to 1916. Starting in 1905, he methodically searched for this object until his death. Understanding that a distant planet would have low brightness, Lowell commissioned a special photographic telescope and astroscope. However, this years-long effort did not yield the desired result. Still, his laboratory staff continued the search for the unknown planet. 14 years after the death of the romantic astronomer, on the 18th of February 1930, his young colleague, Clyde William Tombaugh, 1906 to 1997, discovered the ninth planet. It appeared as a 15th magnitude star in the constellation Gemini. For several months before the discovery, he photographed various sections of the sky each night through a telescope, then repeated the shots several nights later. During the day, he examined hundreds of stars on the resulting photographic plates, trying to find a shifted point, a new planet. The long search was due not only to the small size of the planet, but also to the imprecision of predictions. The new celestial body was discovered 500 million kilometers closer to the Sunday than Lowell had anticipated, and its orbit was significantly inclined relative to the orbits of other planets. Later, a name was given to the long-awaited newcomer. The Greek god of the underworld, who was in Kiev in 1925, received the name New Celestial Body in St. Petersburg. At the end of 1936, when Pluto began to rule the planet where eternal twilight reigns, there was something amiss in Pluto's domain. The distant regions of the solar system still hid many mysteries. As it turned out soon, Pluto was too small to cause the observed deviations in Neptune's motion. Could there be other planets beyond Pluto's orbit, or at least 1/10th planet? At that time, the method of discovering objects with the tip of a pen was popular among astronomers. They calculated the possible mass of Trans-Pluto, this unknown planet that might explain the oddities in Neptune's and Uranus's motions, though proving its existence was impossible. Apparently, it only rarely approaches other planets, as its orbit is extraordinarily elongated. A complete revolution takes 800 years. Currently, it is far from the planets, and its orbit is not elongated. It has moved away from the other planets and does not affect their behavior. It is too difficult to detect, lost among countless stars, and its search would take a very long time. Astrologers, more inclined to accept wishes as facts, even gave it the name Proserpina, as the Romans called the goddess of the underworld. Clyde Tombaugh, fully confident that the solar system did not end with Pluto, continued the search for the 10th planet for 13 years after his discovery. Over these years, he checked 45 million suspicious objects, but all of them turned out to be stars. It seemed that Pluto's orbit should be considered the boundary of the solar system, but other astronomers disagreed. Starting in 1957, American astronomer Henry Lee Dickless, 1910 to 2007, began systematically photographing areas of the sky where Trans-Pluto might be located. This work continued for 18 years. Only in the 1980s, after the flight of the Voyager 2 spacecraft, was the mass of the distant gas giant planets refined. As it turned out, earlier calculations had suffered from inaccuracies. When the new mass values of Uranus and Neptune were substituted into the equation describing their orbits, all the deviations disappeared. It became clear that, later on, when they began to act, the only objects beyond Pluto's orbit could be comets and asteroids. Scientists had already added new planets to the solar system with a stroke of the pen. Now, the pen had to be used to erase potential planets. However, observations of the distant regions of the solar system continued, especially since Pluto itself remained a completely mysterious planet, about which we knew almost less than about distant stars. It soon became clear that beyond Neptune's orbit, myriad small planets were orbiting. The first of them, aside from Pluto and its moon Charon, 1992 QB1, was discovered in August 1992. Its diameter was estimated at 200 kilometers. It moved along an almost circular orbit at a distance of 50 astronomical units from the Sunday. In March and September of 1993, several more asteroids were found at the edge of the solar system. In the following years, discoveries became routine. Pluto turned out to be just the brightest representative of a vast family of small planets that form the second asteroid belt in the solar system, the Kuiper Belt. Today, about 1,500 objects are known to be part of this cluster, a flat ring of enormous width. It begins just beyond the orbit of Neptune, at 30 astronomical units from the Sunday, and may extend as far as 100 to 150 astronomical units from the Sunday. It is believed that this belt is also a source of comets with short and medium orbital periods. In 2005, when the discovery of Eris, a planet the size of Pluto, with a diameter only 50 to 60 kilometers smaller than Pluto's, was announced, astronomers were alarmed that the number of planets in the solar system might soon increase significantly, and they separated the wheat from the chaff. Pluto was excluded, and similar objects were removed from the list of main planets. There are now 8 left. Even if the mysterious 9th planet, which astronomers are once again searching for, is found, it will likely be given some special status, perhaps classified as a major peripheral object. Its orbital plane is tilted significantly with respect to the ecliptic plane. However, it is unlikely that a brown dwarf or an invisible companion star of the Sunday nemesis is hidden in the dark outskirts, as they would likely have been noticed by our telescopes. In 2016, American astronomers Konstantin Batygin and Michael Brown reported in the Astronomical Journal that the mass of this unknown planet should exceed Earth's mass by at least 10 times, and its orbital period around the Sunday could be as long as 20,000 years. It is located 600 times farther from the Sunday than Earth. There, astronomical scales begin. Light would take about 3.5 days to cover this distance, but the story of this planet is a completely different one. Scientists still need to determine whether it is a myth or a fact. Astronomy. The age. Old reign of astrology. The main objections to astrology, the most popular of the pseudosciences, are well known and convincing. Statistics strongly argue against it. According to the results of numerous studies conducted in different countries, the position of the Sunday in the zodiac at the time of birth does not influence personality formation. One example among many cited by Russian astronomer Serdin is the study conducted by French statistician Michel Dequelin. He examined archival data containing the date, time, and place of birth for 41,000 Europeans, including 16,000 well-known scientists, artists, writers, athletes, and 25,000 ordinary people. Dequelin compared the positions of planets and constellations at the time of birth with the person's personality type and occupation. He concluded that there was no correlation between character and profession on the one hand, and zodiac sign, planetary positions in houses, and their mutual aspects at the time of birth on the other. However, up until the 20th century, the primary task of astrology was not to create horoscopes for common people, but to predict future events based on signs sent from the heavens. The stars and planets scattered across the sky, like the cards or dice thrown by a fortune teller, were interpreted by astrologers to advise kings and generals on when to declare war, embark on campaigns, or make peace. Many astrologers believed that throughout time they were unable to see the world, so they waited for the right planetary alignment and observed the celestial sky. Astrology originated in ancient times when fate's blow or the wrath of omnipotent gods could strike people from anywhere, and the only thing left to do was to guess when and where it would happen. If gods descended from the heavens in almost all religions and cultures, then the stars and the glimmer of planets could not fail to reveal the future. It is known that the roots of modern Western astrology go back to the pre-Christian era, to Babylon, Mesopotamia, ancient Egypt, and likely even further, to places where no written records remain. In that ancient time, alongside astrology, the noble practice of interpreting the future, its pale shadow astronomy inevitably emerged. Just as in the Renaissance, an artist would always have an assistant who ground his paints, astronomy was a supporting task. Observing stars and planets, calculating their movement, this was auxiliary work. Only astrology would attempt to make sense of what was seen, correlating one random celestial phenomenon with another, with an earthly event. Their arbitrary coincidences became law. From a scientific point of view, astrology, as it was in the ancient world, is not superstition but a proto-science. That is, a field of study that was not yet a science, as noted by American researcher Lawrence Jerome in his book Astrology and Modern Science, a critical analysis. Searching for patterns in the world around us and describing them is a scientific approach. No wonder the famous German philosopher Ernst Cassirer noted nearly a century ago that astrology fundamentally employs scientific forms of thinking. Causes are analyzed, conclusions are drawn, and final results are arrived at. Astrology was based on the commonly accepted ancient belief that celestial bodies directly influence earthly events. To assess this influence, astrologers, using mathematical methods, identified patterns in celestial phenomena. Since the timing of events was crucial, astrologers compiled detailed tables through long observations, indicating the positions of important celestial bodies at specific moments in time. Using geometric methods, they constructed the orbits of planets. This laid the groundwork for the future science of astronomy. Astrology's history in Europe was turbulent. The ancient Greeks adopted the Babylonian zodiac signs and horoscope construction system. In the 3rd–2nd centuries BC, the Emerald Tablet, attributed to Hermes Trismegistus, appeared. It said, "What is below is like what is above, and what is above is like what is below." The triumph of Christianity in the Roman Empire led initially to the prohibition of astrology. This decision was made by the Laodicean Council in 364 AD, which stated that clergy should not be magicians, enchanters, numerologists, or astrologers. The church persecuted astrologers, just as it did witches, healers, and mimics. All of them undermined faith in God. However, astrology survived these persecutions. Its dual nature, its closeness to astronomy, the science of stars and planets, helped it. In the 8th century, scholarly astrology and astronomy flourished in the Byzantine Empire. In the late Middle Ages, schools infiltrated under the guise of astronomy. By the 12th century, general schools began to appear in Europe, accessible not only to monks. They taught the 7 liberal arts, divided into the trivium and the quadrivium. The trivium consisted of grammar, rhetoric, and dialectics. The quadrivium included arithmetic, astronomy, music, and geometry. In fact, geometry was geography, and astronomy was astrology. During the Renaissance, astrology was popular throughout Europe. Not without reason, in the famous play by Schiller, The Death of Wallenstein, dedicated to the events of the 30 Years' War from 1618 to 1648, its main character, the General Albrecht Wallenstein, in the first scene eagerly gazes at a large blackboard on which an astrologer has drawn the positions of the planets. It predicts an unprecedented triumph for him, a lucky planetary alignment, the great fateful triad. The treacherous, malicious Mars is positioned between the 2 benevolent celestial bodies, Venus and Jupiter. They will subdue the malicious enemy. However, from the title of the play, it is evident how cruelly the stars mock him. Instead of triumph, Wallenstein meets his death. The spirit of the New Age, which belonged to Schiller as well, the Age of Enlightenment, was mocking and arrogant, rejecting this outdated pseudoscience. No physical connection between the movement of celestial bodies and earthly events had been discovered. Interest in astrology waned and only revived at the turn of the 20th century, when the popularity of theosophy, occultism, and spiritualism spread. Astrology found its place once again. A new surge in popularity occurred in the 1960s. Horoscopes as well as astrology enjoyed the greatest success. Among them, there are also astrological predictions. Among the advice and random answers given by them now and then, there will be some accurate ones. Scientists call it a coincidence. But professional astrologers only take pride in their success. Who is right? Let's make another excerpt, this time from the book Expanding the Boundaries of the Universe by Cerdan. In one of his writings, Kepler warned researchers not to carelessly discard star-based superstition, lest they throw the baby out with the bathwater. To this day, the predictive capabilities of astrology continue to be analyzed. So far, no baby has been found in this bathwater, only murky water. As is known, the famous astronomer Kepler composed horoscopes. But here is how he expressed his attitude towards classical astrology. The astrologer who predicts something solely from the sky without considering the character, soul, mind, strength, and appearance of the person to whom they are predicting is on a false path and gives advice on mere luck. So, isn't it clear whether astrology is a science, the geocentric system of the world? This system of the universe seemed to illustrate the famous phrase of Protagoras, "Man is the measure of all things." At the center of the world here rested or revolved around its axis, the Earth. Thus, man was also at the center of the universe. The Sunday, moon, and planets revolved around their mistress, the Earth. This seemed to be an unshakable truth, since people had seen countless fixed stars in the night sky for time immemorial. This led to the belief that the Earth itself was motionless. In this world, embraced by God, only the Sunday, moon, and planets moved in blessed peace. With the development of mathematics, scientists could not avoid believing that these movements could be described and then used to predict the positions of celestial bodies. In its ideal form, the ancient Greek scientist Eudoxus of Cnidus described the movement of celestial bodies as the sum of uniform rotations of several spheres, on the surfaces of which the planets were placed. All the spheres, which came to be known as homocentric spheres, revolved around a common center where the Earth resided. However, the apparent simplicity of this scheme was very deceptive. The ancient Greek astronomers had long noticed certain oddities in the behavior of celestial bodies. The Sunday moves unevenly along the ecliptic. The moon traces a wavy line in the sky. The planets, while moving among the stars, describe strange loops. In their pursuit of precision and harmony, Eudoxus, in order to obtain a qualitatively accurate picture of the celestial movements, combined several spheres for each planet. Thus, the motion of the moon was described by a combination of 3 spheres. The first sphere rotated around a central axis, completing 1 revolution per Dalton Y. The second rotated relative to the previous one every 18.6 years. Finally, the third sphere fixed on the second one made 1 rotation every 27.3 days. The moon was located on the equator of the third sphere. The sum of the rotations in different planes gave a result that matched the observations. Well, from the kinematic point of view, it doesn't matter whether the Earth revolves around the Sunday or the Sunday around the Earth. The distance between them remains unchanged, wrote Russian historian of science Jytomyrsky. Contemporaneous with Eudoxus, Heraclitus of Pontus, based on the fact that Mercury and Venus never move farther from the Sunday than a certain angle, suggested that they revolve around the Sunday. This representation became widely accepted in Hellenistic astronomy. However, the Sunday, like the moon and stars, revolves around the Earth. Thus, Heraclitus introduced the concept of epicyclic motion into astronomy. A celestial body performing this motion revolves around a certain center, which in turn itself revolves around the Earth. One of the greatest philosophers of ancient Greece, Aristotle, 384 to 322 BC, theoretically substantiated what seemed obvious and what Eudoxus had claimed, that the Earth is at the center of the universe. In his book, On the Heavens, he wrote that the Earth must necessarily be at the center and remain stationary, as evidenced by the fact that objects thrown forcefully upwards fall back to the same spot, even if they are thrown to an infinitely great distance. From this, it is clear that the Earth does not move and is not outside the center of the universe. If there were no center like the Earth, the fall of objects would continue forever. Aristotle continued, saying that the shape of the Earth must necessarily be spherical because each of its parts has weight and tends downward to the center of gravity. It will continue to do so until it reaches the center. This model of the world came to be known as the geocentric model, from the Greek geo, meaning earth. It explained many observed phenomena in the sky, but not all of them. Apollonius of Perga and Hipparchus improved upon Eudoxus's theory. However, in order to explain the visible motion of the planets, they had to change the geometry of the universe. The great geometer Apollonius was the first to replace the cumbersome spheres with a clever system of interrelated circles, epicycles, and deferents, a system later associated with the name of Claudius Ptolemy. Hipparchus, on the other hand, suggested that the Sunday revolves around the Earth uniformly and moves in a circle, but the Earth is displaced from the center of this circle. This explains the varying lengths of the seasons. Through observations, Hipparchus determined that spring lasts about 94.5 days, summer 92.5 days, autumn 88 days, and winter about 90 days. He called the orbit along which the Sunday moves the excenter, and the distance between the two centers the eccentricity. He adjusted its magnitude to match his measurements. The task with the planets was more difficult. Their observed movements were too complex to be described using simple geometric models. This task remained unsolved by Hipparchus. The ideal model of the universe by ancient standards was created almost 300 years later by the last of the great Greek scientists, Claudius Ptolemy, 100 to 160 AD. He replaced the simple scheme of Hipparchus, where each celestial body made a single circular motion around the center of the planetary system, with a more complex and accurate scheme of multiple circular motions. This new model could explain the loop-like movements of the planets. Moreover, Ptolemy skillfully modified the system of epicycles and deference so that the movements of the planets could now be predicted many years in advance, and nothing more was required from astronomy at that time. In the simplest case, according to Ptolemy, a planet revolves in an epicycle, whose center moves along another circle, the deferent, around the stationary Earth. To match the theory to observations, additional epicycles had to be introduced. According to Russian astronomer Bronstein, Ptolemy succeeded in selecting the sizes and rotational speeds of all the wheels in his universe, so that the description of planetary motions reached a high point. Ptolemy's system became the crowning achievement of ancient astronomy. It yielded results that perfectly matched observational data. New corrections could be introduced into it, significantly complicating the system, but still achieving the highest accuracy in results. However, this also led to its downfall. For over 1500 years, astronomers refined Ptolemy's system. By the early 16th century, describing the movements of the Sunday moon and the 5 planets known at the time required 77 circles, deferents, and epicycles. Many astronomers began to consider this theory exceedingly complex. This view was shared by the Polish priest and astronomer Nicolaus Copernicus, 1473 to 1543. He sought to make Ptolemy's model more elegant and simpler. According to Copernicus, he took on the task of reading the books of all the philosophers he could find, hoping to discover if anyone had ever suggested that the movements of the celestial spheres might differ from those taught in mathematical schools. Thus, he found the ancient thesis about the motion of the Earth. If one follows this idea, considering that the Earth is merely one of the planets that, rotating around its axis, moves along an epicycle, while the Sunday remains at the center of the universe, then the system becomes much simpler. In this heliocentric system, the number of circles is reduced to 34. Copernicus's system, as presented in his main work on the revolutions of the heavenly spheres, proved useful for calculations. It allowed for the explanation of the apparent motion of the Sunday across the sky, although in its original form it was not fundamentally more accurate than Ptolemy's. However, the transition to the heliocentric system, where the Earth revolves around the Sunday, radically changed all concepts of the structure of the world, and this was soon followed by the discoveries of Galileo, Kepler, and Newton. Therefore, Copernicus's theory became the foundation upon which all modern science is built. In search of the anti-Earth, for more than 2 decades since the discovery of the first exoplanet, a planet lying beyond the solar system, astronomers have been searching for a second Earth, a planet with conditions similar to those on Earth. The anti-Earth, or antiton, was also a twin of Earth, but it was not to be found in distant star systems. It was supposedly located very close to us. It was said to orbit along the same path as Earth, moving synchronously with it, and thus was always hidden behind the Sunday's disk. This hypothetical planet was like a tantalizing object for ancient astronomers, close yet unreachable. Positioned just 2 astronomical units away from us, at a distance equal to 1 Earth orbit's diameter, it remained undetectable by earthly telescopes. Ground-based telescopes made it easier to observe distant galaxies than to spot this elusive planet, deceiving us. However, with the advancement of space exploration, it became clear that such an anti-Earth did not exist. The idea persisted for a long time, The first mention of it dates back to the 5th century BCE. The Greek philosopher Philolaus, 470 to 388 BCE, described it. A follower of the mathematician Pythagoras, Philolaus created a school that attributed reality and real power to numbers. In the late 5th century, the mystical Pythagoreans stirred up resentment among their fellow citizens, who eventually dealt with them brutally. According to legend, Philolaus was one of the 2 survivors. Ancient authors note that Philolaus was the first Pythagorean to reveal their teachings, including those about the structure of the universe. He wrote a book on nature, of which only fragments have survived. In this work, he described the cosmological system. The 5th century Byzantine writer summarized this fantastic cosmological model. Philolaus placed fire at the center of the universe, which was called the hearth of the universe, the home of Zeus, the mother of the gods. He also accepted another fire, located above everything, serving as the encompassing fire. The first fire was the central fire. Around it, in a circular dance, revolved 10 divine bodies, the sky and the planets, followed by the Sunday, then the moon, the earth, and the anti-earth, with the fire again after all. In another version, Earth was not a single body, but consisted of 2 independent hemispheres, Earth and anti-Earth, separated by a gap along the equator, through which the heat of the sacred flame penetrated the heavens. In this system, the anti-Earth, moving synchronously with Earth, remained invisible, because it was always obscured by the body of Earth. Modern researchers note that Philolaus's hypothesis would have been easy to test by organizing an expedition that could cross even a quarter of Earth's circumference. However, as Jodorowsky ironically pointed out, for that era such a proposal was equivalent to suggesting that modern astronomers travel to the center of the galaxy to check for a black hole. The expedition was impossible also because, unlike other Greek astronomers, Philolaus believed the Earth was a flat disk. We live on the side of the Earth that always faces away from the central fire and is directed toward the Sunday and other planets. Therefore, life is possible here. The terrifying fire does not burn the world completely. Only its particles illuminate and warm the inhabited part of the Earth. The Sunday, according to Philolaus, is translucent and reflects the fire from the cosmos. The reverse side of the Earth, facing the anti-Earth and the central fire, is uninhabitable. We do not know how accurately John Stobæus described this mystical teaching which originated 1,000 years before him. For example, Aristotle in his Meteorology, while commenting on the astronomical theory of the Pythagoreans, explained the origin of the anti-Earth. Since the Pythagoreans defined numbers as the origin of all nature, they applied this concept to all definitions and parts of the sky and nature. Where something did not align, they sought to fill the gap to create harmony. For example, the number 10 seemed to them to be the most perfect, encompassing the entire nature of numbers, so they said there were 10 moving spheres in the sky. However, since they observed only 9 such spheres, they invented a 10th, the anti-Earth. Regarding the 9 mentioned spheres, these were the spheres of the fixed stars and the 7 planets: Saturn, Jupiter, Mars, Venus, Mercury, the Sunday, and the Moon, as well as the sphere of Earth. But was the anti-Earth created only to achieve numerical harmony? In the Pythagorean cosmos, it had an important role. All celestial bodies were considered etheric, light bodies with very little mass, while Earth was a massive chunk of solid matter. This wouldn't have been a problem if Philolaus, like other Greek astronomers, had placed Earth at the center of the universe, but instead it orbited the central fire. In that case, if the massive Earth was located at the periphery of the universe, its center might not coincide with its center of gravity. The harmony of the celestial spheres would have been disturbed. Philolaus, or someone from the Pythagoreans whose teachings he transmitted, balanced the Earth by positioning a planet, just as massive as ours, on the opposite side of the central fire. In Aristotle's model of the universe, this problem could not exist. The Earth itself, having the perfect shape of a sphere, remained immobile at the center of the universe for the next 1,500 years. All other planets, the Sunday, and stars surrounded the Earth. In this majestic cosmic image situated above us, there was no refuge for the anti-Earth. From the mid-1/6th century, since the time of Nicolaus Copernicus, Earth left the center of the universe, yielding it to the Sunday for several centuries. In this updated model of the universe, suddenly there was room for Earth's antipode, the French mathematician Joseph-Louis Lagrange, 1736 to 1813, analyzing the motions of celestial bodies, discovered that a specific point, located behind the Sunday, was special. Today we know 5 so-called Lagrange points. Any celestial body positioned in one of these points can remain there indefinitely, because the forces acting on it, including the gravitational forces of the Sunday and Earth, are balanced in these points. Only external forces can cause this object to leave a Lagrange point. So where are these points? 2 are located near Earth. One is between Earth and the Sunday, and the other is on the opposite side of Earth. 2 more are located along Earth's orbit, ahead and behind Earth, deviating from it by 60%. The last of these points, officially called L3, is where the anti-Earth should have been, on the far side of the Sunday, along the orbit Earth follows. Theoretically, there could be an unknown planet there. Let's assume the age of space exploration has not yet arrived. In practice, this is impossible for the following reason. Lagrange performed the calculation within the framework of the 3-body problem, ignoring the influence of all other planets except Earth. However, they too exert some influence on the planet in the L3 point. Calculations show that within just a few million years, gravitational disturbances will wobble the anti-Earth, and it will, having left the Lagrange point, collide with Earth. Today, scientists are confident that if the anti-Earth had formed simultaneously with Earth, the 2 planets would have collided around 4.5 billion years ago, soon after the formation of the solar system. Earth was spared because the likelihood of 2 identical planets forming at the same distance from the Sunday is very low. In search of the 7th and 8th heavens, the world of Mid-Europe emerged from the ruins of the Roman Empire. It is not surprising that their conceptions of the cosmos were inherited from antiquity, primarily based on the works of Plato. Particularly important for medieval science was his dialogue, Timaeus, which is the only systematic outline of Plato's cosmology. Written several centuries before the triumph of Christianity, it is regarded as a kind of apology to God the Creator. Plato constructed the cosmos as a unified whole composed of whole parts, perfect and unaffected by decay or illness. By means of rotation, he rounded the cosmos into a spherical shape, the surface of which is equally distant from the center everywhere, thereby giving the universe the most perfect outline of all. In the 12th–13th centuries, the works of Aristotle and Ptolemy began to reach Western Europe from Byzantium and the Arab world. The fortunate discovery of Aristotle's works proved to be fateful for Europe, as they represented a complete rational system that explained the entire world in its entirety, based on natural causes, emphasizes Australian historian of science Alistair Crombie in his book Od von Yate, From Guston to Galileo, The Emancipation of Natural Sciences. Such an approach aligned with the spirit of the High Middle Ages, a growing tendency to rationalize all aspects of life, including faith. The most visionary aspect was revealed in what Christianity had initially sought but could not obtain: a philosophical system that could be harmoniously combined with Christian doctrine, and thus promised to become the rational foundation for dogmatics and an instrument for apologetics, wrote Dutch historian of science Eduard Dijkstra Hoes in Mechanization of Worldview. The works of Aristotle and Ptolemy, translated into Latin, sparked intense debates in which the leading scholars of the High Middle Ages, including John of Sacrobosco, Roger Bacon, Albert the Great, Thomas Aquinas and Robert Grosseteste participated. These debates formed a rational view of the surrounding world and cosmos. What, then, was this cosmos like? The medieval cosmos was divided into the sublunary world and the heavenly spheres rising above it. The Earth rested motionless at the center of the universe, surrounded by a system of concentric heavenly spheres. On the outermost, highest of all, beyond human sight, resided God. The heavenly spheres, immune to change, represented perfection itself. The sublunary world, the earthly world, was shaken by change and metamorphoses. Everything here was unstable and fragile, filled with weaknesses and flaws. In the early Middle Ages, the system of the world was straightforward. Above the Earth, the spheres of the Moon, Sunday, planets, Venus, Mercury, Mars, Jupiter, Saturn, and the fixed stars were arranged in succession. The planetary spheres slid perfectly relative to one another. They were completely transparent, being made of quintessence or ether. Each planet was attached to its sphere. It was commonly believed that stars and planets were made of the same ether as the heavenly spheres. We see them only because the density of ether in them is unusually high, which is why they reflect sunlight or glow on their own. All these heavenly bodies were different manifestations of eternity. They could never be destroyed. The only change they underwent was uniform circular motion, which could last indefinitely. Medieval scholars usually added 2 more spheres to this ancient scheme, revealed in the revelations of the Holy Scripture, the Bible. In the opening verses of the book of Genesis, it says, "And God made the firmament, and divided the waters which were under the firmament from the waters which were above the firmament." It was believed that the center of the waters above the firmament was the crystalline sphere. It was considered the first cause of the movement of all the other spheres beneath it. Blessed souls of virtuous people and saints were often believed to dwell there. Finally, in this sphere and its surroundings lay the Empyrean, the kingdom of God, and celestial beings, angels, archangels, and saints. The great Portuguese poet Luís de Camões praised this empire in his poem The Lusíada, saying, "And the first orbit, in the brilliance of its turning, encompasses the lesser spheres, which with fiery, unyielding brilliance set limits to sight and reason. That is the Empyrean, the abode of the blessed, the divine destiny of high souls, where they taste eternal happiness, which is unknown in the vain world." However, just as if hundreds of people suddenly dreamed the same dream and, upon waking, began to record its fragments, only to find that they were all writing about different things after comparing their notes, medieval authors left us very differing descriptions of the cosmos, revealed to them through reading ancient authors, their reflections, and visions. For instance, the Anglo-Saxon chronicler Bede the Venerable wrote only about 7 heavenly spheres, following the Bible rather than ancient models. Nonetheless, French historian Jacques Le Goff noted that Bede's cosmology, even in its terminology, clearly reflected Greek heritage. Directly above the Earth stretched the sphere of air, above it the sphere of ether, and further the sphere that contained all the planets. Bede called it Olympus because the planets were named after Greek gods. Heavenly fire blazed above these nearby heavens. Sometimes it reminded people of the polar lights, the ominous flight of a comet, or the swift streak of a meteor, as was believed in the Middle Ages. Above this sphere stretched the vault of the fixed stars. Higher still rested the sky of angels. And the 7th heaven, where the Holy Trinity resided, closed the world. Bede's cosmology is interesting because it shows how an educated man of the 8th century imagined the universe. The Christianization of this concept, continues Lego, culminated in its simplification, as evidenced by the 12th century work of Honorius. In this concept, we see the story of Augusto Dunensis, who distinguished only 3 realms: the physical sky that we see, the spiritual sky where spiritual substances, i.e. angels, dwell, and the intellectual sky where the blessed contemplate the face of the Holy Trinity. Other authors, when contemplating the heavens, avoided such what might be considered a regrettable minimalism. The British mathematician and astronomer John Sacrobosco, author of the Desphai era around 1230, which remained a standard astronomy textbook until the 17th century, preferred the arrangement of spheres followed by Aristotle. After the Moon, he placed Mercury and Venus, followed by the Sunday and the other planets. Almost all representations of the celestial spheres that appeared during the Renaissance and modern times adhered to this model. Thomas Aquinas, who lived from 1225 to 1274, also referred to ancient authorities. Pythagoras says that there are 10 spheres moving in the sky, of which only 9 are visible from Earth. These are understood through the movement of the 7 planets. The 8th is through the movement of the unchanging stars. The 9th, due to the appearance of the day, is the first mover. Dante Alighieri, who lived from 1265 to 1321, constructed his universe from 9 heavens. He combined the crystalline heaven and the first mover into one, and he did not consider the Empyrean as a separate heaven. Now, if we turn to how medieval scholars imagined, in modern terms, the near-Earth space, that which stretched between Earth and the Moon, we find that there were 4 additional invisible spheres. They consisted of the 4 ancient elements: air, fire, earth, and water. The elements were arranged according to their specific weight. Closest to the center was the earth, surrounded by water, above which stretched the air, and finally, up to the sphere of the Moon was spread the celestial fire. Here, it should be clarified that the Earth's sphere should not be identified with the Earth itself. This sphere simply consisted of the element called Earth. Medieval theologians saw it as an illustration of the biblical verse about the firmament, which rests between 2 waters, and God called the firmament heaven. At the end of the 16th century, Italian philosopher and astronomer Giordano Bruno publicly spoke about the imperfection of the celestial spheres. Almost all astronomers before him, including Copernicus and Kepler, believed that the cosmos was limited by the sphere of the fixed stars. Bruno, however, declared that the universe is infinite, and all the stars visible to us are the same as our Sunday, only located very far from us. Around them, planets orbit, and these planets are also inhabited by intelligent beings who may not resemble us at all. A century and a half before Bruno, similarly bold ideas were presented by Cardinal Nicholas of Cusa, 1401 to 1464, the closest advisor to Pope Pius II. He asserted that the universe has no boundaries, that it is infinite. The machine of the world, he said, has its center everywhere and its circumference nowhere, because God is both the circumference and the center, as he is everywhere and nowhere. Now, with Bruno's bold declarations, the celestial spheres finally fell, releasing the countless stars scattered into the infinite distance. But in this universal catastrophe, the destroyer of medieval cosmology perished as well. By that time, science and theological dogma had irreconcilably parted ways. Bruno did not await the title of cardinal, but the stake. For his sacrilegious words, for his merciless denouncement of myths, he was, by the custom of the Inquisition, burned. The execution took place during the times of Cervantes and Shakespeare, Kepler and Galileo. Tycho Brahe's System of the World. In 1588, the famous Danish astronomer Tycho Brahe published a book titled On the Recent Phenomena in the Celestial World. Based on the results of his astronomical observations, he sought to reconcile the irreconcilable. The old, rejected teachings and the new, already rejected by ecclesiastical and spiritual systems. He decided to combine the world system that had been considered infallible for 1500 years with the world system that had been rejected for half a century. In this year, he concluded that all these systems created in 1580 were made from spiritual contradictions. Thus, Tycho Brahe decided to take the best aspects of Aristotle's physics Ptolemy's geocentric world system and Copernicus's heliocentric world system, which shifted the Earth and made it revolve around the Sunday. This story began in November 1577 when a bright comet appeared in the sky. Since ancient times, comets had been considered omens of disasters. People feared that its devilish glow, which flared up above the world, would signal an impending war or plague. The deceptive fire of the comet burned for 3 months. These months were fortunate for Bra, as he regularly observed the comet. Aristotle had once argued that the lights of comets were nothing more than atmospheric phenomena. The superlunar world was inaccessible to them. It was eternal and unchanging. This was the belief of the time. However, the results of Bray's observations and those of other astronomers showed that this comet was 3 times farther away than the Moon. It moved as though piercing the celestial vault. Her path intersected those heavenly spheres with which, as Aristotle believed, the planets move. Does this mean that these spheres do not exist? Brahe set out to write a book about comets. But sometimes a book becomes like a ship that, after setting sail, suddenly returns to take on board another very important passenger. Into Brahe's book, dedicated to recent phenomena seen in the sky, suddenly found its place a new system of the world, which he had formulated. Here is how he explained its necessary appearance. I believe that the old Ptolemaic arrangement of the heavenly spheres was not elegant enough, and that the assumption of so many epicycles, through which the apparent motions of the planets relative to the Sunday are explained, should be considered excessive. At the same time, I believe that the recent innovation of the great Copernicus, whose ideas resemble those of Aristarchus of Samos, subtly eliminates those parts that are unnecessary and inconsistent with the Ptolemaic system, doing so without violating mathematical principles. However, the body of the Earth is large, slow, and unsuitable for motion. I have no doubt that the Earth we inhabit occupies the center of the universe, which corresponds to the views of ancient astronomers and natural philosophers, is testified by the Holy Scriptures, and does not revolve in annual motion as Copernicus desired. But how did he manage to reconcile the irreconcilable ideas, dueling with each other as fiercely as combatants? What did he sacrifice to reconcile the enemies? What compromise seemed to him a new word in science? Brahe was not only a great astronomer, but also an excellent engineer and mechanic. He made most of the instruments he used himself. To increase the accuracy of measurements, he enlarged the sizes of the instruments and invented new methods of observation, seeking to minimize any errors. For example, he developed a special sight for the armillary sphere. As noted by Zhytomyrsky, Brahe was the creator of the most accurate instruments of pre-telescope astronomy, but it was precisely the confidence that his measurements were the most accurate that troubled him. If, with his instruments, he could not observe the annual parallax of the stars, their apparent motion, and they remained stationary, even though the Earth, as the great Copernicus claimed, moves and should cover a distance twice as great as that separating it from the Sunday, then perhaps Copernicus was mistaken after all? Quietly, Brahe wrote in 1589 to his assistant, the German astronomer Christoph Rothmann, "Do you think it possible that the distance between the Sunday and Saturn would not even be 1/700th of the distance from the sphere of fixed stars? Yet this must certainly be the case if the Earth's annual path, as seen from the fixed stars, must be only 1 minute of arc. But then, even the fixed stars of the 3rd magnitude, whose apparent diameter is also 1 minute, should have the size of Earth's orbit." He could not believe either that the sizes of the stars were so gigantically large, or that they, so similar to planets, could be bodies of an entirely different nature, much brighter. Now we understand that when looking at the sky, we see not the true sizes of the stars, but the brightness emanating from them, the apparent brightness, which we call stellar magnitude. In Brahe's time, astronomers thought otherwise. The Danish scientist was unlucky. He was the last great astronomer living before the invention of the telescope. In the 17th century, Scientists realized that the fixed stars had no visible diameter at all and appeared to the naked eye as just luminous points. The parallax of the stars closest to the Earth was only detected in the first half of the 19th century. Not only Brahe's instruments but also telescopes in the following 250 years were unsuitable for solving this problem. Understanding well what he did not like about Copernicus's system, Brahe proposed a system kinetically equivalent to the heliocentric one, but free from this flaw. In the same book, he wrote, "Since, I say, I thought about the fact that both hypotheses, those of Ptolemy and Copernicus, allow many absurdities, I began to deeply reflect on whether it is possible, through any reasoning, to discover a hypothesis that would not contradict both mathematics and physics, would avoid theological condemnation, and at the same time fully correspond to celestial phenomena." In Brahe's system, like in that of the ancient Greek scientist Heraclides of Pontus, who lived from 388 to 315 BC, all planets except Earth revolved around the Sunday, while the Sunday itself, along with the sphere of stars, revolved around the Earth. This model perfectly explained the peculiarities of planetary trajectories and even predicted the phases of Venus, which were only discovered with the invention of the telescope. From a purely computational perspective, it was no different from Copernicus's system, but it had an important advantage: it was not condemned by the Inquisition. Brahe was proud of his system of the world, but it did not play a significant role in the history of astronomy, although it intrigued his contemporaries. There are two known instances when other astronomers tried to claim it as their own discovery. Among its few supporters was the Italian astronomer Giovanni Battista Riccioli, author of the book New Almagest, which represented a compendium of astronomical knowledge of the time. However, Riccioli modified Brahe's geoheliocentric system. He further limited the power of the Sunday, making Jupiter and Saturn also revolve around the Earth. But this innovation did not help. Brahe's system was rejected by most scientists in the 17th century as unnecessarily and artificially complicated compared to Copernicus's system. The latter finally triumphed. At the mercy of magnetic forces, in the early 17th century, it was discovered that a strict mathematical order reigned in the solar system. Each planet moves along an ellipse, which resembles an elongated circle, and apart from the center, it has two foci. One of the foci is always occupied by the Sunday, so the planet alternately approaches it and moves away from it. As this happens, the planet's speed changes as well. When the planet nears the Sunday, it speeds up, and when it moves farther away, it slows down. The farther the orbit is from the Sunday, the slower the planet moves along it. But what maintains this order in the heavens? In classical celestial mechanics, Aristotle's star sphere, stretched over the earthly world, had a first motion which descended along the lower celestial spheres to the nearest planets, including the Moon. The creator of the new celestial mechanics was the German scientist Johannes Kepler, 1571–1630. He was the court mathematician of Holy Roman Emperor Rudolf II. After the death of Danish astronomer Tycho Brahe, Kepler gained access to a large archive of his astronomical observations. Based on Brahe's records, Kepler derived the law of planetary motion in 1601, known as the law of areas. For equal time intervals, a planet sweeps equal areas of its orbit. This is now known as Kepler's second law. The radius vector of a planet sweeps equal areas in equal intervals of time. In 1605, Kepler formulated another law. Each planet moves in an ellipse, with the Sunday located at one of its foci. This later became the first law in his set of laws. In 1609, Kepler published his book Astronomia Nova in Heidelberg, where he outlined both laws. His theory of planetary motion became Kepler's greatest achievement. The full title of his famous book is Astronomia Nova, the cause and effect physics of the heavens, presented in the Researches on the Motion of the Star Mars, based on the observations of the nobleman Tycho Brahe. This long title was not by accident. Kepler's goal was not only to describe the visible phenomena, but to understand the causes of everything happening in the heavens. Unlike Aristotle, he believed that the motion of the planets was predetermined by the Sunday. It rotated and pulled the other planets along with it. But what force did they obey? From our school years, we know that planets move around the Sunday under the influence of gravity. The credit for discovering this law belongs to Isaac Newton. However, several decades before him, when thinking about the motion of planets, Johannes Kepler was already convinced that some invisible force emanated from the Sunday, which all the planets obeyed. Could it be the same force that makes iron filings obediently follow a magnet? In the 17th century, interest in the mysterious magnetic force steadily grew. In 1600, English physicist William Gilbert published his work on the magnet, magnetic bodies, and the great magnet, Earth, in which he summarized all the observations and research accumulated over the preceding centuries. Based on these facts, René Descartes, in his Principles of Philosophy 1644, suggested the existence of a special magnetic substance. Many visible phenomena that we observe originate from it. Descartes wrote this after Kepler had already linked the greatest celestial phenomena occurring before our eyes, the movement of the planets in their orbits, to something similar to magnetism. It should be noted that Kepler was a diligent reader of Gilbert's book, and the actions of the magnet described there reminded him of the events taking place in the heavens, giving him a key to their understanding. There exists some divine force, Kepler proclaimed in his book, Harmonies of the World, 1619. This is a kind of magnetic force, the soul of the mover. It emanates from the Sunday like its rays and imbues it with light. The Sunday affects the souls of the celestial bodies, urging them to move along defined orbits. The Sunday literally instills this force into the planets revolving around it. Much like, according to the impetus theory of that time, any mover transfers the moving force to the object under its influence, which then urges the body to continue moving. This hypothesis was revolutionary, especially since in 1936, Kepler was in Cyprus. At that time, it seemed impossible that a force could act over such vast cosmic distances. The intensity of this quasi-magnetic force acting on each planet is proportional to the distance from the Sunday to the planet. Just as the intensity of light decreases as we move away from its source, the same happens with the soul of the mover. And the farther the soul of the mover is from the Sunday, the more noticeably the amount of motion of any celestial body decreases. The idea of the soul of the mover appeared to Kepler quite early, around 1600. In his correspondence, he used the expression the ability of the mover, or the force of the mover. This clearly emphasizes that in later years, when using the term soul of the mover, Kepler was firmly breaking away from Aristotle's concept. Even when he said soul of the mover, he really meant the force emanating from it. Let's assume that Kepler was mistaken in believing that this force had a magnetic nature. He described what was happening in the heavens according to the physical understanding of his time. Today, historians of science consider his soul of the mover to be a scientific myth, but it is a very plausible myth, despite the fact that Kepler, in his attempt to re-establish celestial mechanics, did not take into account the influence of planetary mass or the mutual influence of the planets on each other. The general scheme he drew of the motion of celestial bodies was correct. The laws Kepler derived from observations were later used by Newton to establish the law of universal gravitation. Newton proved that under the influence of mutual attraction, two bodies, the Sunday and any planet of the solar system, would move according to Kepler's laws. The soul of the unseen engine, this soul of the mover, in a metaphorical sense, became the force of gravity. One of the major discoveries in physics in recent years, the discovery of gravitational waves in 2015, for which the Nobel Prize in Physics was awarded in the fall of 2017, again encourages us to recall Kepler's magnetic force. As we now know, gravity propagates, as well as electromagnetic waves across vast distances. We now see how cryptocurrency moves within the cryptospace, leaving a lasting influence in its wake, similar to electromagnetic waves. The two theories of Kepler and Newton rejected and widely accepted, truth and myth are once again converging. Within the error, in the myth, we find ideas without which the truth would be incomplete. Was there a planet called Phaethon? The existence of this legendary planet was believed for a long time. This belief was supported by the highest power of science mathematics. Perhaps it was Johann Kepler who first spoke of this planet in 1596. He was very interested in the vast empty space between the orbits of Mars and Jupiter. It disrupted the celestial harmony. Kepler sought a law that would connect the orbital periods of the planets, but it turned out that with only 5 known planets, such a law was impossible to find. So he boldly proposed 2 new planet zones between Jupiter and Mars, and another between Venus and Mercury. In 1766, German mathematician and astronomer Johann Daniel Titius formulated an empirical rule that allowed the approximate calculation of the distances from the Sunday to the planets known at the time. It turned out to be incorrect. But in 1766, when Johann Kepler looked at the Sunday, he realized that the distances followed a simple numerical sequence. It works as follows. Take the sequence 0, 1, 2, 4, 8, 16, 32, multiply each member by 0.3, and then add 0.4 to the results. This creates the sequence 0.4, 0.7, 1, 1.6, 2.8, 5.2, and 10. These numbers correspond to the distances from the Sunday to the planets, including Saturn. 1 astronomical unit is equal to 150 million kilometers, which is the average distance from Earth to the Sunday. Today, this law is known as the Titius-Bode rule, because it became widely known after the work of German astronomer Johann Elert Bode in 1772. This law matched the arrangement of the planets in the solar system, except for one. At a distance of 2.8 astronomical units, 400 million kilometers from the Sunday, no planet had been discovered. But this is what the mathematical law required. When the planet Uranus was discovered in 1781, located exactly at the distance predicted by the rule, the missing 5th planet seemed to be found. However, astronomers soon embarked on a systematic search for this hypothetical planet. Success came to Italian astronomer Giuseppe Piazzi on the night of the 1st of January, 1801. He discovered a small planet which was named Ceres. The long-awaited discovery was made, but it was soon overshadowed by further discoveries. New planets were found in quick succession: Pallas, Juno, and Vesta. It was at this time that German astronomer Heinrich Wilhelm Olbers, 1758-1840, who discovered Pallas and Vesta, proposed that all the discovered small planets were fragments of a once large planet that had broken apart. A contemporary of Hoffmann and Chimizo, Olbers even indulged in romantic fantasies, suggesting that this planet, like Earth, was once habitable and perhaps still could be. But in 1780, when the planet Uranus had not yet been discovered, it was named Ceres. There, he imagined, a civilization might have existed. The destroyed planet was named Phaethon. The name echoed the ancient Greek myth in which Helios, the Sunday god, rode across the sky every day in a chariot drawn by 4 fiery horses. One day, his son Phaethon decided to drive his father's chariot, but the horses did not obey him and veered toward Earth. Zeus struck the chariot with a lightning bolt. Phaethon perished, the fiery horses fled, and Earth was saved. Some enthusiasts even believed that the planet Phaethon was destroyed during ancient Greek times, and that the famous myth was a poetic account of a catastrophe that shook the Greeks. In reality, the asteroid belt lies between Mars and Jupiter, and Ceres turned out to be just the first of them. The famous French astronomer Urbain Le Verrier 1811, 1877, attempted to determine the possible mass of the planet Phaethon. Certainly, like other scientists, he was convinced that many asteroids had not yet been discovered. However, his knowledge of celestial mechanics still allowed him to estimate the total mass of all the known yet undiscovered small planets. To do this, Leverrier decided to calculate how the asteroid belt influences Mars's movement in its orbit. By knowing the gravitational impact, it would be possible to calculate the total mass of the asteroids. According to Leverrier, the asteroid belt was the main asteroid belt on Earth. Returning to this, Leverrier calculated how the asteroid belt might affect Earth. As a result, astronomers were unable to compute the mass of the asteroids. Consequently, Leverrier's estimate did not exceed 0.1 minus 0.25 of Earth's mass. Other astronomers, not trusting the conclusion of the prominent scientist, tried to compute the mass of Phaethon themselves. It turned out to be just as small. Today, astronomers are even more skeptical of Leverrier's results. They believe that the mass of Phaethon is overestimated by at least 10 times. If the missing planet were made from the asteroids, it would be no bigger than the Moon. Recall that the Moon's mass is 0.012 of Earth's mass. It is likely that a planet could not have formed in this part of the solar system. When the giant Jupiter formed, it gathered all the material, all the planetesimals, the embryos of future planets that were relatively close to its orbit, in the region where Phaethon should have appeared. Meanwhile, astronomers of past centuries even studied Phaethon. They believed that it was, contrary to calculations, supposedly larger than Mars but smaller than Jupiter. It was located on the boundary of the habitable zone of our solar system, between cosmic life and death. There, as Olbers thought, life could have arisen and did, but beyond it, there was a lifeless expanse. Scientists made many guesses trying to understand what kind of catastrophe befell this unfortunate celestial body. For instance, American researcher Charles Koval proposed that 175 million years ago, Phaethon collided with an asteroid and shattered into millions of fragments. These fragments, like bombs, continued to rain down on neighboring celestial bodies. For example, Mars has a crater 600 kilometers in diameter and 25 kilometers deep. Could this phenomenon be the result of the shattered Phaethon? Moreover, many of its fragments entered the gravitational fields of Mars, Jupiter, Saturn, and Neptune, becoming, like many others, part of celestial bodies. In this world, as in many others, there were fragments that ended up in the heavens. This hypothesis, which evolved into a legend, especially intrigued with the fate of the two largest fragments. For thousands of years, these shining fiery spheres orbited the Sunday. Later, one of these comets allegedly transformed into the 9th planet, Pluto. The other, as hypothesized by American researcher Immanuel Velikovsky, became the morning star Venus. At one time, the orbit of this comet repeatedly crossed Earth's orbit, causing terror among humans. The danger was real, wrote Velikovsky, who was not believed by any serious scientist. Earth would frequently be knocked off its orbit, leading to apocalyptic events, earthquakes, volcanic eruptions, floods, and fires. Climate catastrophes occurred repeatedly. The alternation of seasons was disrupted. Only around 800 BC did the cosmic bombardment cease. The last shells scraped Earth, and the gravitational forces calmed down. Since then, the comet with its fiery tail, in other words, the planet Venus, peacefully orbits the Sunday. However, over time, the legend faded. The hypothesis did not withstand practical testing. Later calculations showed that there was never a planet Phaethon. Between Mars and Jupiter, there were only tiny planets. Since 1983, the name Phaethon has been assigned to an asteroid, which however does not belong to the asteroid belt, but is much closer to Earth. Venus's moons are leaving. The cloud cover had long obstructed the study of Venus's surface through telescopes. There were no prominent landmarks, red spots, or dark seas. Scientists couldn't even accurately determine the planet's rotation period. For a while, they believed Venus did not rotate. Venus always faces the Sunday with the same side. It wasn't until 1961, through radar observations, that it was discovered that Venus does rotate, but very slowly. Time passes quickly on Venus, and one doesn't even notice it. A day on Venus lasts 243 times longer than on Earth. If humans could settle there, a year's worth of events would be published in the daily newspaper. Venus's day, however, is shorter than its year. It lasts 225 Earth days. This beauty, sometimes lively, sometimes languid, orbits the Sunday faster than it rotates around its axis. Everything is mixed up here. Why does Venus rotate so slowly? Perhaps at some point it had a huge moon that slowed it down. Powerful tidal forces generated by this moon heated the planet. This didn't last long, and after several 100 million years, this moon, becoming Mercury, left Venus. Since then, our celestial neighbor has remained a scorching, sluggish planet. Of course, this is just a hypothesis, but it has yet to be disproven. In 2006, Alex Alimi and David Stevenson from the California Institute of Technology published a radical hypothesis. According to it, Venus collided with another celestial body in the distant past. This body shattered, and its debris formed a moon around Venus. It resembles the theory of the Earth's moon's origin. However, after another collision with a large celestial object, Venus began rotating in the opposite direction, causing its moon to move closer to the planet rather than drifting away like the moon does from Earth, until it eventually crashed into Venus. Nevertheless, confirming this hypothesis is difficult because the intense volcanic activity on Venus has transformed its surface, erasing all traces of ancient catastrophes. The Venusian moon had already been discovered. In 1672, Italian astronomer Giovanni Domenico Cassini, who lived from 1625 to 1712 and was the first director of the Paris Observatory, noticed it. Initially, Cassini doubted his discovery and did not publish any reports about it. However, 14 years later, he rediscovered the object and made a note of it in his observation journal. According to Cassini, the moon appeared to be large, with a mass only 4 times smaller than that of Venus. Later, this same moon was observed by other scientists. In 1740, English astronomer and optician James Short saw it, and in 1759, German astronomer Andreas Meyer. In 1761, Joseph Louis Lagrange also observed it. Specifically, Lagrange noted that the orbital plane of Venus's moon is perpendicular to the ecliptic. That year, 1761, was special because, from time to time, the Sunday, Venus, and Earth align in a straight line. At this moment, if you look at the Sunday through binoculars or a telescope, you can see a small black dot moving across its disk, Venus. This phenomenon, known as the transit of Venus, is very rare, occurring once every 100 or so years. It repeats after 8 years, and then it must be waited for another century. During this event, for over 2.5 centuries, the attention of astronomers has been focused on Venus. The fate of these astronomers has often rewarded them with discoveries. For example, on May 26, the 6th of June, New Style, 1761, Russian scientist Mikhail Vasilyevich Lomonosov discovered the atmosphere of Venus. That year, 5 astronomers observed the moon of Venus 18 times. One particularly interesting observation came from German astronomer Abram Scheuten. On the 6th of June, he saw Venus passing across the Sunday's disk, accompanied by a small dark spot. However, British astronomer Samuel Dunn failed to see this moon next to Venus on the same day. In 1764, 2 observers noticed the moon 8 times. Others tried to do so but were unsuccessful. The debates heated up, with some stubbornly denying the moon's existence, while others saw it flickering across the sky with remarkable regularity. In 1766, Father Maximilian Hell, director of the Vienna Observatory, proposed that all observations of this elusive moon could be explained by optical illusions. He argued that the brightness of Venus's image caused reflections, which led observers to see the moon. While some laughed at the misunderstanding of their colleagues, others did not waste time. In 1777, German astronomer Johann Heinrich Lambert, 1728 to 1777, considered one of the founders of photometry, established key concepts regarding Venus's moon. In 1877, Lambert published detailed findings about the moon in the Berlin Astronomical Annual, and in 1927, he identified a number of photometric regularities. According to his calculations, the moon orbits at an average distance of 66.5 radii from Venus, which is the same distance that the moon orbits Earth. However, this figure did not quite match the orbital period Lambert had calculated, which was 3 hours and 24 minutes. The uncertain situation regarding Venus's moon persisted until the end of the 19th century. In 1884, Belgian astronomer Jean-Charles Ozo put forward an unexpected idea. He noticed a pattern in previous observations. The moon was spotted every 1080 days, or 2.96 years, on average. Perhaps we are not dealing with a moon but with an independent planet? In that case, Venus itself would be the distinguishing planet, orbiting the Sunday and approaching Venus once every 3 years. This phenomenon is called a conjunction. Ozo gave this planet the name Neith, after the Egyptian goddess of hunting and war, whose image was forbidden to mortals. However, 3 years later, the Belgian Academy of Sciences published a comprehensive report on the observations of Neith. It turned out that all these sightings were stars near Venus. The scientists noted that the stars' positions were uncertain on average, but they were still able to identify them as stars. For example, James Short had actually observed a star with a magnitude less than 1/8. Similar explanations were given for the observations of Urbain Le Verrier and Jacques Montanet. Copenhagen astronomer Christian Horrebow likely saw the star Theta from the constellation Libra in 1768. Danish astronomer Retger also made a significant contribution by identifying 2 stars from the constellation Orion and one from Taurus and Gemini as Venus's moon. Unfortunately, all of Lambert's orbital calculations turned out to be incorrect. After the publication of this revelatory document, only one case of the observation of Venus's moon remained known. On the 13th of August, 1892, American astronomer Edward Emerson Barnard, 1857-1923, who had previously discovered the Horsehead Nebula, noticed an object near Venus with a star magnitude of 1/7. No star should have appeared at that location. It was well known that Barnard's vision was exceptional. Even today, we don't know exactly what he observed. It might have been an asteroid passing by Venus, or perhaps a supernova briefly appearing somewhere behind Venus. If it was the latter, he wouldn't have been able to see the star's magnitude. However, he might have seen this flash in a way that no other astronomer noticed, but no one else ever saw Nate again. However, astronomers now know that Venus has a pseudo-moon. This is the asteroid 2002 VQ-68. Orbiting the Sunday and sometimes crossing the orbits of Mercury and Earth, it closely mimics Venus's movement. Their orbital resonance is exactly 1:1. The second moon. In the 19th and 20th centuries, astronomers several times claimed to have discovered a new satellite of our planet, a second moon. But each time the discoveries were not confirmed. This story began in 1846, when the director of the observatory in Toulouse, Frédéric Petit, announced that his colleagues Lebon and Doucet had discovered another tiny satellite of Earth on the evening of the 21st of March, 1846. After verifying their observation, Petit calculated that the second moon orbited Earth in an elliptical orbit, completing one revolution in 2 hours, 44 minutes, and 59 seconds, with an apogee distance of 3,570 kilometers and a perigee that brought it to within just 11.4 kilometers of Earth's surface. That year, the moon, like all other Earth satellites, was involved in the discovery of the second moon. Enthusiastic about the idea of a second moon, Petit even suggested that some peculiarities in the motion of Earth's main satellite could be explained by the influence of this tiny planet. However, his colleagues ignored his discovery. It might have been forgotten if not for the popular 19th century writer Jules Verne. He read about the discovery of the second moon, and this profoundly influenced the fate of his characters. In his 1869 novel Around the Moon, the spacecraft launched to the moon became its companion. The situation seemed dire, but the characters were fortunate to encounter the small celestial body, the second moon. "Is it possible?" exclaimed Michel Ardan. "Does Earth have two moons?" "Yes, my friend. It has two moons, although it is generally believed to have only one. But this is not as we think. No, it's not as we think. Yes, we think it's not as we think. This second moon was so small and its speed so high that the people of Earth couldn't notice it. Only by observing the disturbances it caused did French astronomer Messier Petit manage to detect its existence and calculate its orbit." "Do all astronomers acknowledge the existence of this moon?" asked Nicole. "No," replied Barbicane, "but if they, like us, met it here, they could not doubt it anymore." Their encounter nearly led them to collide with the second moon. Though it didn't happen, the spacecraft changed its trajectory and eventually returned to Earth. Millions of people read this popular science fiction novel, remembering both this significant scene and the discovery supposedly made by the French astronomer. Successors to his work emerged. In 1898, Georg Walthermat from Hamburg reported the discovery of an entire system of tiny moons of Earth. He specified the exact parameters of one of them. The second moon, according to Walthermat, had a diameter of about 700 kilometers and orbited Earth at a distance of 1 million kilometers, completing one revolution in 119 days. Walthermat also suggested that sometimes this moon was mistaken for the Sunday. He referred to the American polar explorer Adolf Grill, who allegedly observed the solar disk for 10 days after the polar night in Finland. Walthermat also predicted that on the 2nd of February 304, 1898, the second moon would transit across the Sunday's disk. His prediction garnered attention. On the 4th of February, the post office in Greifswald, Germany, transformed into an observatory. A good dozen observers leaning out of the windows stared at the Sunday blazing above them. They, along with the post office director Mr. Ziegel, his family and colleagues, tried to help the astronomers. The sunlight was blinding, but they managed to discern a dark spot slowly moving across the Sunday's disk, which was about 5 times wider than the spot itself. Was the discovery confirmed? It soon became clear that, at the same time, 2 experienced astronomers, Winkler from Jena and Baron Ivar von Benko from Pola, Austria-Hungary, were also observing the Sunday but found nothing remarkable, only common sunspots. Thus, the discovery turned into a mistake. However, Walthermat didn't give up. He continued to predict where the second moon could be found, but it eluded observation again. In 1903, American astronomer William Burns, who had been studying the solar disk, made an inconvenient remark about the search for this planet, publishing an article about a photographic search for the moon's satellite. All the attributes discussed about this hypothetical object could also apply to observations of the second moon. The article suggested that a satellite with a diameter of 30 centimeters, located 320 kilometers from Earth's surface, could be seen with a 3-inch telescope. A satellite with a 3-meter diameter would even be visible to the naked eye. But by 1903, when the satellite was supposedly established, it wasn't even visible to the naked eye. If it wasn't visible, the satellite's diameter must have been less than 3 meters. This brings us back to Petit's idea that the second moon influences the movement of our main satellite. This would only be possible if the second moon's diameter were a few kilometers. But then, it would have been noticed long ago, perhaps even in Babylon. In 1922, the same journal published an article by Pickering specifically dedicated to the second moon, this meteorite satellite. It sparked excitement among enthusiasts, as it stated that a 3 to 5-inch telescope with a low-power eyepiece is best suited for searching for the satellite. This became an activity for amateur astronomers. Just a few years later, the German astronomical journal Dijkstern reported that German amateur astronomer Spill had discovered such a satellite on May 24, 1926, while it was crossing the lunar disk. However, like other similar discoveries, this one did not lead to further developments. The search for the second moon even once again bridged astronomy with astrology. In 1918, English astrologer Walter Richard Walt gave this celestial body the name Lilith. Walt believed it was black in color, and therefore it could not be observed with astronomical instruments. Only when this black moon passed across the solar disk could it be seen. Just as authoritatively, the astrologer stated that in terms of mass, Lilith was comparable to the moon, without considering that such a massive body would influence the motion of the Earth. Leaving aside the astrologers, it's possible that Petty, Spill, Walthemat, and their colleagues were not mistaken at all. Perhaps they were simply discovering transient satellites of Earth. After all, sometimes our planet captures whatever it can. Some scientists also believe that the moon occasionally captures a small object that has drifted close to it. Calculations show that such a satellite would inevitably crash onto the surface of the moon after a few years, possibly surprising stargazing enthusiasts once again. The search for the second moon has not ceased even in modern times. In 1997, Canadian astronomer Paul Viget noticed a small asteroid, 3753 Ruffin, which was moving along a very strange orbit. It seemed to be a satellite of Earth. However, further observations showed that this was not a faithful companion of Earth. It did not orbit the Earth, and thus it was a temporary companion. Similar pseudomoons, such as 2002 AA-29, 2003 YN-107, and 2010 CO-16, were later encountered by astronomers. Subsequent analyses by two astronomers stopped the silver light and Flora Ray.